Well, hello. How's everybody doing? Anything happen while I was gone? Anything? No? No, nothing? Nothing? Everything's fine? Just another Friday? I'm reading. Give me a second. Missed you last night on console for your real-time failure analysis. I told you they should have scrubbed. Told you that they should have scrubbed. Just saying. That's all I told you. So I said they should probably scrub. They didn't listen to me. They didn't. It's just a coincidence. But also, told you. So, you sure? Nothing you want to talk about? You want to talk about it? You sure? Now, let's play KSP. Oh, okay. I am reading about closed cycle gas generation startup procedures. No reason. There's just no reason. I'm just give me a second. Wasn't here last night. What's the theory with the second stage? I can get into it in a second. I just actually need to find this. I'm not even trying to be funny now. Hang on, let me read. Give me 1 second. I know, this is, see, internet, this is called a book. I know. No real pain, but I'm worried about the rest of the weekend. Book. Cringe. That ain't a gun, that's a book. One second. New. Give me 1 second. That's a geared turbo pump. That's not what I want. Turbo pump. That's a transmission design. No. Ah, I'll have to go through and look after it later. So, Shaw got his wisdom teeth pulled. No cringe. Oh, okay. Thanks. I didn't know what this was. So, what I'm looking through is design of liquid propellant rocket engines that just happens to chroma out. That's teal. Why is that chromaing out? Whatever. Doesn't matter. Weather guy, 51 months. So,
Discovery, go at throttle.
I didn't find exactly what I was looking for, but doesn't matter. I had to do some studying last night. If you guys, so Starlink 9.3 went out of Vandenberg last night, and I don't want to be like overbearing, but it failed. Yeah, it didn't work. Well, best case scenario, partial failure. Something funky happened. Not with the first stage or anything. Pretty typical Vandenberg launch here. Here, let me show you.
4, 3, 2, 1, ignition, and liftoff.
So, yeah, everything went fine here. Everything was looking okay. You'll see.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
Now, I did appear to see some stuff coming off right there. I'm not 100% sure what that is. That's not ice. That is a piece coming off. So Yeah, unless induced, pieces falling off your rocket, generally a bad thing.
Stage 1 propulsion is nominal.
Yeah, there's whatever those are, they're definitely falling
Stage
off the
1
vehicle.
propulsion is nominal.
It worked until it didn't. Well, it's very interesting. This one's a little bit of a tricky one. But we'll do some deductive reasoning here. Possibly the Velcro patch they put on the second stage for the Starlink arms to impact during deploy. Okay. SN11's corpse be like, I told them not to launch in the fog. That's Vandenberg's secret int. It's always foggy. So once again, this is a replay of the footage from last night. So everything here looks fine. Like I said, we noticed some crap coming off here, but I've reviewed this footage. I was up way too late last night looking at this over and over and over again. I did not get a lot of sleep, which is why I ended up being a little bit late for the stream today. But let's take a look. Everything here looks pretty fine. I do not think this problem is GSC related, although Hellfish, you shouldn't really rule out anything. This is a weird one. This is a very tricky, very, very tricky. It's very strange. I've isolated it, I think, to one area based off of what we've seen. I don't know anything that you guys don't know.
And back started.
So, right here is where stuff starts to get a little funky. And back chill. So, there was a problem with the second stage motor, and you'll see it in a second. But you know what? Let's just go through the whole thing.
And back chill has started.
When we go for our breakdown, we'll start at 135. Now watch. Falcon 9's flames are a little bit asymmetric there because it's burning radial out relative to velocity vector. Basically, that means it's pointing more up than straight. They do that to get squeeze a little more performance out of the first stage. That vapor is off nominal. That's actually supposed to be there, Jim. That is the vent lines from the second stage from the chilling mechanism. Now, see that? When we were down here a little bit earlier, little puffs of smoke, totally normal. Or, well, it's condensation. That, not normal. So, this is where things start to really get funky.
Main engine cut off.
Watch. I'm just going to play it. I'll just play it. You guys watch. Tell me what you see.
And back ignition.
That's not normal.
Fairing separation confirmed.
Just watch. Once again, this is a replay from the Starlink 9.3 last night. Tell me what you see. You guys just take a look. If you see something weird, look at the timestamp and then tell me about it later. There is a bunch of things I'm seeing here that are not good. Not ideal. Not ideal. Actually, very bad. I'm frankly amazed that motor is still functioning. Yeah, you'll see. When I point it out to you, you'll know it when you see it. It's not good.
Discovery, go at throttle up.
Now, believe it or not, the most apparent thing that you're about to see is not the thing I'm actually worried about. To be 100% honest. Hey, Ellisers. Believe it or not, that over there, not what I'm concerned with, believe it or not. There is... Booster 12 is doing a spin prime right now. Cool. Ooh.
Discovery, go at throttle up.
Personally, I already know that because it's been talked about all over the internet. Yeah, so... That's not good. French Invader, 27-month resub. The Falcon Mouse is still there. And also, there's something weeble wobbling around on that thing. Booster 12 completes its spin prime. Yeah, see that? Not ideal. That's also bad. It looks awesome though. Yeah, it looks crazy. Clearly something extremely wrong here with the second stage. Once again, we're just gonna play through the whole thing, and I'll you guys point out stuff. What is that white stuff? I'll get more into that, Linus. Let me just tell you that that's not supposed to be there. It's not supposed to be. It's not supposed to look like a winter wonderland in front of the engine. Okay.
Entry burn startup.
Supersonic retro propulsion, first stage, just doing its thing. I thought all the callouts were nominal. Well, Vin, we'll get more into that because there's some interesting things to take note of here. All right, we're gonna be here for a while. I'm gonna basically be here all the way up until the flame trench, looking at this. Yeah. So sit back, relax, get the popcorn. Hopefully, enjoy your Friday. That's really bad. See, that's not good. That up there, yeah, that's not. I mean, the motor's still working, but not great. 8-Bit Tidbit is continuing the sub they got from Tessa. Right on. It's like a secondary or a tertiary line came loose. Why is it not good? SPR, long story short.
Oh,
This is space. I'm in space. Laserman, what's up, man? Thank you for that resub. 29 months and then gifted a sub to Bishamoda. Bishamoda. Thank you very much. Why is that not good? The SPR or SRP, this is not me being intentionally vague.
Stage 1 transonic.
We've watched a lot of Falcon 9 launches.
Stage 2 FTS is saved.
Like 300 plus. It's never done that before. That's how I know it's not good. It's never done that. You get some snow coning on the Merlin engine or the Merlin vacuum engine, but you don't get that. First stage coming through. Everything looks real good except for whatever's moving around in front of the camera there. Something's clearly...
Stage 2 is in terminal guidance.
Stage 1 landing leg deploy.
First stage came down, did its thing. Great landing.
Stage 1 landing confirmed.
Perfect. $25.2, $25.3, $25.4, $25.5, 6, 7. Speed's increasing. Everything's good. But Mylar's full of something. Something. That is so cool. Yeah, Peace Frog. Every time. Once again, this is a replay from last night.
And back shutdown.
So the ice is a problem. Got it. Yesterday, got a job offer about space engineering. The project is cleaning the space from decrepit satellites. Why did Nightbot axe that message, SPR? I don't... That's weird. What's terminal guidance? Terminal guidance or closed loop? Oh, problem.got. Oh, okay. I thought you were typing in a URL. Got it. Yeah, SPR. Forgive that timeout. I can see. Yep, it had a link in it. Okay. Problem.got. Get got. Yesterday I got a job offer about space engineering. The project is cleaning the space from old satellites. Running in Oxford. I need to decide. But one more thing. What about my City Skylines save file? Oh, geez. Yeah. It's low. I'm not gonna lie. I'm only telling you the truth because I know you. It's not high on my priorities list, man. I'm sorry. My fingers are in too many pies right now. Anyway, well, let's talk about that later. Now let's get back to this. So, what do you see? Timestamp it, guys. Did you do what I said? I said look at times. Look at the times. What did we see? Everything, well, there's not much to tell right here. Everything looked fine from the startup procedure. Now, we get into liftoff here. I know. Thank you, though. That's all good, man. All good. All right, so I'm going to break down this footage here. Stuff's coming off. Stuff is coming off the launch vehicle. That's clearly not ice. It's clearly man-made. That is a piece of Falcon 9 coming off. That's not good. Whether that has anything to do with the Winter Wonderland that the second stage made, don't know. Hard to say. Whatever it is, we saw a bunch of pieces coming off here. There's more of them, whatever that stuff is. They clear to be similar pieces, but I don't know what they are. Oh, it always comes back to that freaking pie. So, roll program looks good. Everything looks fine. This all looks okay. Now, 135. They start Merlin vacuum chill down. So what does that mean? When you turn on a rocket engine, guys, you don't just hit the go button. I mean, they do, but that's not... There's a bunch of staged events that need to happen. You basically got to do... If you own a lawnmower, for instance, that's gasoline powered, you have to prime the motor, right? You have to prime the motor, and then with rockets, you have to get it to the right operating temperature. So you don't want to start the motor without the motor being full of fuel. So how do you do that? There are what's called pre-valves in the second stage that allow a small amount of flow to go into the second stage engine, the Merlin vacuum engine, okay? We'll get more into what the Merlin vacuum is and how its propellant actuation works in a second here. This is going to be a deep dive, and this is going to take a while, so hold off questions for a second. This might be the cover for the hole in the fairing. It is a similar shape, Thor. Yeah, we'll have to look. If, you know, maybe when NSF gets pictures of those fairings coming back in, we can see if they're there. So, Merlin vacuum. They have to start chilling down the motor. So that's what the call for MVAC chill is. What are they doing? They're opening up pre-valves in the second stage that are allowing small amounts of propellant to basically drip into all the turbine machinery, all the plumbing on that second stage. Now, you obviously don't want to flood the rocket engine with fuel and oxidizer, even though that's what they're doing right now. Hey, Elizers. Thanks for the $10, man. I appreciate it. Real quick, what's the name of the Starlink launch? 9-3. So, if you flood anybody here have an old car? If you flood the engine, what happens? Nothing happens. You don't want to fill the combustion chambers with propellant on a car engine. A rocket engine's the same way. There is some type of mechanism that I'm unfamiliar with that prevents the propellants from getting into the injector plate, or at least getting near, well, not into the injector plate. Basically, there's some type of valve system that prevents the propellants from going into the rocket's combustion chamber. You do not want to flood the rocket engine when it's still attached to the first stage. You're asking for an ignition when you don't want it when you do that. So, when the Merlin vacuum engine chills, they flood the engine with RP1 and liquid oxygen. It doesn't make it all the way through the whole plumbing, but what that really is there for is to cool down the turbine machinery, okay? So the reason why you want to do that is because, one, you don't want to dry fire a rocket engine. That can create problems. You'll basically create drag in the propellant lines because there's air in there and not liquid. And air in the propellant lines for a liquid fuel rocket engine is not good for it. You know why? Because it has liquid fuel rocket engine in the name. So air going into it, anything but liquid fuel, anything but RP1 and liquid oxygen going into a Merlin vacuum engine is bad for it. That's just a good rule of thumb for rocket science there. So they chill down this motor. They start moving the propellants in. That's what MVAC chill is. The other thing is that because you're using liquid oxygen, you have to chill the turbo pump down to operating temperature. The liquid oxygen is super cold, right? But when the liquid oxygen starts flowing into that turbine machinery, the liquid oxygen is going to exchange the heat with the turbine, right? Because it's at room temperature, and the liquid oxygen is minus 200 C almost, right? Or minus 293 Fahrenheit or something like that. It's really freaking cold. The turbine machinery is not very cold, so it has to exchange the heat. So what happens when that happens? The liquid oxygen goes in, it exchanges the heat with the turbine machinery, and the liquid oxygen heats up. It absorbs the heat. What happens to the liquid oxygen then? It turns to gas, and that gas goes out vent lines. You've seen these vent lines before if you've watched a Falcon 9 launch, okay?
MVAC chill has started.
Okay, MVAC chill has started. Now, everything seems to be okay here. The pre-valves are open. You can tell because you see something going on the left side here. Okay, so where this camera is on Falcon 9, we are at the 9 o'clock position relative to the vehicle. Meaning if the vehicle is flying up like this, 12 o'clock position would be on the top, 6 o'clock would be facing the ground, 3 o'clock is that way, 9 o'clock over here is this. That RCS block is 270 degrees counterclockwise around Falcon 9. So the bottom of the vehicle is over here, and the top of the vehicle is over here. So 12 is over here, 6 is over here, 9 o'clock's here, 3 o'clock's on the other side. Why do I bring this up? There's two sets of vent lines. Why are there two sets of vent lines? The vent lines on one side are for oxygen, and the vent lines on the other side are for RP1. Remember, they're flooding the engine, but you don't want to flood the combustion chamber because you risk a detonation event, what's called a hard start. So you can see the liquid oxygen is coming out this side. Remember that, okay? We don't see much venting over here, but generally you don't want to vent gaseous RP1 and gaseous oxygen right next to each other, because when they flow down the stack, they're going to find a source of ignition down here. Spoiler alert, that's a little hot. So you vent on either side. The vent lines are on each side of the vehicle. Now, there could be ox vent lines over here, but generally you don't. It could be that there's two oxidizer vents on either side. I'm just not familiar enough with Merlin vacuum, with the Merlin vacuum engine. I've never had to look into it, right? We've never had to. But now is the time. So we can clearly see that we're venting over here. But that just could be because of the sunlight. They could be venting on both sides. Just keep that in the back of your mind here. This right here, we know that the pre-valves on that second stage engine are open because, well, the vent line is venting. We know the pre-valves are open. So the pre-valves are working. Right? Pretty straightforward stuff. You could see gaseous oxygen flowing down the stack. Right there. Now, that's normal. This is what we normally see. That's fine. Hey, Chief. Hot. What's that, Phil? I'm kind of in the middle of something. Okay, yeah, we'll get to that in a second. So this is normal. That's the amount that you should... Uh-oh. Now, interesting thing here. Flow rate out of that vent line started to pick up, and then it stopped. Just something to note. But now it's not stopping. Now it's getting really bad. That's not normal. We're venting. I'm going to go ahead and guess that that's gaseous oxygen. Could be RP1. It's possible. But RP1, this is an industry standard for rocket propellant 1 or highly refined kerosene. It's dyed red because RP1, it basically looks like a clear liquid. So in the industry, to detect leaks, they put red dye into RP1. So if we were leaking RP1, it would look blood red. That's on purpose. I think it's very safe to say that that's leaking oxygen. A lot more than what's intended. SpaceX confirmed that it's a LOX leak. Oh, that's good, Elisers. I'm just telling you what I see here, okay? Bear with me. So, like I said, you don't want to flood the rocket engine. We're looking up the plug here to make sure that the second stage is centered inside the interstage so the nozzle doesn't hit anything during separation. This is a pneumatic system, and there's a plug in the throat to make sure that nothing gets up in there. It looks like just a little nub on the top. We can't see inside of the combustion chamber in this picture, but I think it's safe to say that whatever is leaking is not leaking into the combustion chamber. Once again, pre-valves. There's a pre-valve system. Pre-valves from the tank to the turbine machinery, and then there's another set, your main valves, that go into the combustion chamber. If the main valves were leaking, it would look like Christmas in here. That's definitely not what's going on here. It's something with the pre-valves or something associated with the thermal conditioning system.
Main engine cut off.
There's Miko. Now watch stage separation. So pause real quick before we get there. See those? Those are your vent lines right there. Why is there 3? I'm not 100% sure on that one. To be real with you, there's 3 more on the other side. Now, once again, if I had to guess, you'd be venting LOX on one side and RP1 on the other. Inside of this Mila blanket, that's just space. That's a space blanket. This is a thermal protection system, albeit not like a tile or anything. It's a thermal protection system to make sure that the temperature of the turbine machinery doesn't get too hot or too cold in the vacuum of space. It's really easy to go one way or the other. It's hard to keep it balanced. This is a thermal protection system. Where's your turbine machinery in this design? So, the Merlin vacuum engine is a closed cycle gas generator engine. What does that mean? Closed cycle means that the gas generator gets recirculated into the nozzle. More on that in a second. He said more on. Gas generator. How does a gas generator work? Well, it's about as simple of a design for a rocket engine, for a vacuum engine that you can get. I think the only thing that might be simpler is an RL10, but what an RL10 makes up for in simplicity, it lacks because you're using a complicated propellant like hydrogen. Hydrogen is a little bit harder to use than kerosene. This does burn RP1 and liquid oxygen just like the first stage engines do. The reason why is because when SpaceX designed this rocket, Elon insisted on using propellants that are easier to move around, which makes sense. That's a good place to start. Use something simple, right? So how does this engine work? Well, what happens is you have here. Let me get you guys some diagrams. That's not exactly a good one. This isn't exactly how this works, how a Merlin vacuum works. That's why I don't want to use this. This is a regeneratively cooled design. Merlin vacuums, the plumbing on it slightly changes from this. Merlin vacuum is a film cooled design. So see this red line right there? That red line doesn't happen. The red line here would go right to that point right there. It would just go over here and down. But this more or less is the right idea. And also there's another thing. The turbine is not in the middle in this design. The turbine is over here because of this loop-de-loop. The oxidizer and the fuel pump are basically going right in. Now, so what happens in this design? You have a pre-burner and you have your control valves. Those are the main, or those are the those are your main valves that I was telling you about, guys. The pre-valves would be up here. They'd be upstream from this design, okay? So that is a little too different to be able to explain that correctly. Let me try to see if we have a better design here. Let's just type in Merlin vacuum engine. That will probably get us a little bit of a better idea. Seeing if we can get a dang picture of one. There, well, that's a picture of one. This is off Teslarati here. All right. So that's a Merlin vacuum over here. So check it out. There's your fuel and oxidizer lines right there. There's your vent lines. See them? They vent at the turbine machinery because, like I said, you do not want propellant going into your combustion chamber. So how this works is, let me just double check to make sure I know I can see what I'm looking at here. Okay, your gas generator is down here, like I thought. See that? That's the gas generator. So what does the gas generator do? They spray small amounts of RP1 and liquid oxygen into this. It blows up and it spins a turbine wheel in here. And then it gets shot out the exhaust this way. More on that later. That's what makes it closed cycle. Now, up here you have two fluid impellers, or two pumps. Right there is your main liquid oxygen. That's liquid oxygen fuel pump. That's your RP1 fuel pump. They're inside of housings. How do I know that that's the LOX pump? It's insulated. Remember, liquid oxygen is cold. That one is not. RP1 doesn't need to be insulated. There's your vent lines right there. I'm not sure which three hook up to what we see over here, but you get the idea. Now, the pre-valves would be controlling propellant flow into this and into that. They do not control flow into the gas generator. Why? Well, you don't want the gas generator turning on, right? You don't want to mix fuel. The only place you really want to mix fuel is inside of the rocket's combustion chamber, and you want to make sure you do it at the right time. When you go to start the engine, you don't want it to ignite before you tell it to ignite. It's not Starship. It's not hot staged, right? So that's very, very simple introduction. The turbine from the gas generator spins. It spins the two fluid impellers. The fluid impellers pump fuel into the main combustion chamber, which is behind here, and then they go out the nozzle. Now, it's important to understand this. I said that this is a film-cooled rocket. It's a film cooled. So most rocket engines need to have a way to shed heat. Okay? They get hot. They get really freaking hot. So how does it get so freaking hot and not melt the damn metal? So first of all, there's some really, really rare earth metal composites and probably Inco or something here. Not composites, they're alloys, idiot. It's not carbon fiber. There's some really, really strange metals that get put into this for cooling purposes. And that's how they shed all the heat. But one of the ways that they do it is, keep in mind, you can opt for two different types of cooling mechanisms. One of the ways that they do it, and this is what makes it closed cycle, is the exhaust. The exhaust from the turbine here, the gas generator turbine, gets recirculated through a manifold. See the manifold right there? It gets recirculated into the manifold for the engine. And that gives you a cool column of gas between the inner nozzle wall and the explosive stuff that's happened, the hot gases that are being accelerated out, the explosive stuff that's happening in there. That is called film cooling. Okay? The gas is a little film. It's a little thermal medium between the really hot propellants and the really hot nozzle. Now, why do you do that? Fuel, RP1 is very good at absorbing heat. There's a reason why I call RP1 diesel fuel's cousin, because it is in a long line of petroleum products, boy. It's its cousin. Now, anybody that knows basic principles of operation for a diesel engine, you'll know that diesel fuel is really good at absorbing heat. Why? It's really good at absorbing heat because that's how a diesel engine works. Diesel fuel and oxygen need to absorb enough heat to be able to auto combust. That's how a diesel engine works. For the people that don't know, diesel engines have no spark plug. All a diesel engine does is move a piston up and compress diesel and atmosphere to the point where it'll explode on its own because so much heat is generated from gaseous compression. RP1 is very similar in that regard. It's very good at absorbing heat. So, they run this gas generator very fuel rich on purpose. One, that's to keep the turbine blades from melting. Two, that's to provide film cooling on the engine. That film cooling is what is that fuel, the fuel-rich mixture that's being dumped out here. Fuel-rich means they're delivering way more fuel than way more oxygen. The fuel that does find the oxygen blows up, and that makes something really, really hot, right? The combustion, it makes a lot of heat. The remaining fuel that is unburnt gets absorbed. It doesn't get absorbed. It absorbs the heat. And the gas shoots out into the nozzle through this recirculation manifold. That's called the closed cycle. Okay? So this is a closed cycle, liquid oxygen, RP1, vacuum engine. Okay? Now, second part of how a Merlin vacuum engine cools itself, and this is important to understand here. The nozzle extension here, if you notice that Merlin vacuum in this picture doesn't have any extension. There's an extension piece that gets attached to it when it goes to fly. It's that big gray thing right there. That thing is probably about 3 meters tall. It's gigantic. It's about 10 to 15 feet. It's tall. You could stand inside of it easily. But what this thing is made out of is it's made out of niobium. And now if that means nothing to you, it's a super rare earth metal that is very good at absorbing and radiating heat. More on that later as well. Okay? Yes, it's using D's metal. Niobides. Nidesium. Yeah. Lignesium. Anyway. So, the nozzle, they have some film cooling, but film cooling is only going to get you so far with this big of a nozzle. So the nozzle actually glows to keep itself cool. I've talked about this many times. All right? That's the closed cycle, and then they use black body radiation. So if the nozzle is glowing, it's cooling itself. Now, getting back to this. We have main engine cutoff, and you're about to see stage separation from the 9-3 mission last night.
Stage separation confirmed.
And back ignition.
I noticed some things here. There's some things going on here that I'm not sure I like. Now, how am I qualified to talk about this just in case anybody's coming in here? How am I qualified to talk about this? I don't know. I've been watching tons of these launches. Does that make me an expert? No. Am I a nerd? Yes. I know what to look for, and I know what looks normal and what doesn't. We've seen a lot of this stuff. I'm a loser that spends most of my time reading about rocket engines all day, so I can better give these explanations. I actually had to study today to be absolutely sure. Now, during separation, this part of the separation looks fine. Those vent lines, the vent lines from the thermal conditioning on the engine are supposed to separate, and they did. They separated just fine.
Separation confirmed.
On both sides. We got good separation on both sides. Now, what do you notice here? The vent lines are venting a little bit, but they ain't venting what they vented before. So what does that mean? Pre-valves are closed. Main valves are going to open here in a second because the engine is thermally conditioned and ready to go. Now, sometimes the Mylar wrap does inflate. It happens from time to time because sometimes air gets caught in there when it goes up into the vacuum. Yo, send it. What's good, man? But one of the vents right there is clearly working. It's clearly doing its job. Now the other one, no.
And back ignition.
Now you'll see the vent line stays open because there's no valve for the vent line. They always do that. That's totally normal. Okay? This is fine. This happens. Now, what I noticed is if you look at the left-hand side camera here, clearly this thing is venting something. There's something else going on here. Something else going on that causes the entire second stage to kind of slew to one side. Watch. It picks up a slight yaw rate here. Look.
And back ignition.
See? The whole stage, the whole second stage is tilting to one side. Now, what does that mean? Something here, because we noted that those pre-valves were closed. They are. They're absolutely closed. We didn't see any venting right at stage separation. However, something is venting in here right now. The bag's inflated. That Mila is inflated. And whatever it is, it's causing the stage to yaw. It's venting down at the bottom, so it's tipping it to one side. Now, the engine starts up just fine. The startup looked fine. Startup looked completely normal. But you saw that second stage, the guidance system seemed to correct for it. Now watch. It'll kind of slew back and forth. See? Look over there. See it slew? It picked up that yaw rate when it started the engine. This is thrust vector controlled, meaning there's a hydraulic system here that is steering this engine independent of the fuel tanks. It can steer it like a rudder almost, right? The thrust vector control and the guidance system picked up on that yaw rate, and it used the thrust of the motor, turned the thrust of the motor slightly offset to compensate. But you still saw the second stage move around a little bit. That means something is leaking down here. I think we can be very clear of that, right? Now, it's interesting to me how dirty the left side looks on the camera. What it's doing is that's soot deposit from... So... Interesting. That's interesting to look at, Hawks. I said a little bit earlier that these engines run very fuel rich. Unburnt fuel does get shot out of the nozzle because that's the fuel that was used to pick up the heat, right? It was used to pick up the heat from the engine to cool it. That's that film cooling. Falcon 9 rolls coal. That's what I'm trying to tell you. And some of that gets deposited as soot. That's what all this dirty stuff is.
State separation confirmed.
Now, once again, you see the separation was good, but something happens here. Those pre-valves are shut. Main valves are open here because you see propellant getting shot out. Now, here, whatever it is, it's on the gas generator side of things, right? Just because of the way the stage slewed around. How do I know? Oh, actually, hold on. Let me take a look at this. Let me just watch this again real quick.
And back ignition.
Yeah, it is the gas generator side of things. So what do I mean by gas generator side of things? So if you look at where Falcon 9's 3 separation actuators are and the hold down mechanism, 1, 2, and 3, right? With this camera, you have 2 on the right-hand side, 1 and 2, relative to the horizon, and then you have a singular one on the left side. That's that one right there. So these cameras, one of them is here on the rocket and the other one's 90 degrees offset during separation. This camera is down over here somewhere. It's down in there. We can't really see it because it's dark, and the exposure on this camera is designed to deal with sunlight, so it's very dark in there. But you can see 1 and 2 on the separators. So that means the turbine machinery on this picture, where the leak is on this side. So it's a leak from the turbines. Not necessarily from the turbine. Sorry, I didn't mean to... I'm jumping to conclusions there. It's a mat with different conclusions that you can jump to. It's something on the power pack side of things. Now, once again, what's the power pack? That's this thing. There's a leak clearly coming from somewhere over here. Now we know our pre-valves are closed. The pre-valves are closed and the main valves are open. The main valves are, well, the valves that control propellant flow into the injector plate. Right? Well, injector plate, gas generator, basically wherever you need the rocket fuel to go when the engine is starting. Though the main valves control that. Now, obviously, we see propellant coming out. When they go to start this engine, that's when that stage starts to slew. That's when it picks up a yaw rate. See it move relative to the horizon. So it's something to do with startup. Absolutely something to do with startup here. Startup is what shocked the system to exacerbate whatever leak that is. So, you know, it's something that's in line. It's something where the propellant would go during MVAC chill down, right? So when they thermally condition the engine, and where propellants are going to go during startup. That could be 1,000 different things, but just I'm picking off easy ones, okay? No, absolutely not sabotage. No. We'll get more into that in a second. So the vent valves are working right there. This is just a straight tap off, and we do see these vent valves working. Now, here's the interesting thing. On the opposite side of the turbine machinery, you don't see much coming from over here. This is these two shots, right? These two shots are on opposite sides. These two cameras of the second stage. There's two of them. One is looking at one side of the nozzle and the other's looking at the other. These are 180 degrees offset of each other. So the other camera is on the same side looking backwards like this. If the engine is going this way, the two cameras are like that. Why does SpaceX have these cameras? They have these cameras to watch the nozzle cooling mechanisms. They're not here for our entertainment. They're watching to make sure that the nozzle is uniformly cooling itself. How do you know if it's uniformly cooling itself? Well, the glowing on the nozzle should be nice and symmetrical. There shouldn't be any obvious cold spots on the outside of the nozzle. Now, with that being said, watch the nozzle. So the nozzle starts up, it starts absorbing the heat, and the niobium will start radiating the heat. See? And it starts to glow. Emissive. That looks fine. This is how it should look. You know, it's not going to be perfectly uniform. An explosion is a violent and chaotic event. It's not going to be perfectly uniform, but it's going to be close. Like that, that's okay. See this? I'm wondering a little bit about that little guy right there, but this is good enough. Now watch what happens when they switch back to the other camera here. Uh-oh. That's concerning. See that? That's not good. Something is cooling too much of that nozzle. Whether it's the inside or the outside, we don't know. See that? That's bad. That's very bad. Why is non-uniform cooling in the nozzle bad? Well, when you have metal, any type of metal, you heat it up and you cool it, it expands and contracts, right? It's absorbing energy, so it expands a little bit. Any type of metal, or any matter for that matter, right? It expands. You don't, with a nozzle, you want the gases that are inside of that nozzle to uniformly push on every side of this nozzle. If you get nice and uniform pushing on the outside of the nozzle like this, structurally the nozzles will stay nice and rigid for you, right? Because it's almost like it's being inflated like a balloon. It'll stay strong. But also, you're expanding the metal evenly. You don't want a cooler spot on the nozzle because the molecular structure of this the niobium and whatever the heck they make this out of is expanding and contracting at different rates. That's bad. That's not good. Because remember, like I said, you're inflating this. Picture, say you had a balloon, right? And you were inflating this balloon and there's a nail next to it. You go to inflate the balloon and the balloon starts to push on that nail. Eventually it's going to pop. The rocket engine kind of works similar to this, right? That non-uniform heating is a thorn in the side, for real. That's really bad. I've never seen a Merlin vacuum engine do that before. So, let's think about this. Where is that? What is that in line with? It's in line with the turbine machinery. Uh-oh. Now, an important thing to note. Motor's working just fine. Motor's fine. It's operating completely normal right now. Now, also, something is floating around in front of the first stage camera here, and I don't know if that's the camera lens cover or something, But something came off here, and something is kind of just sitting in front of the camera. I have no idea what that is. That's not supposed to be there, I'll tell you that.
Fairing separation confirmed.
Fairing separation looked fine. I don't think there's anything to note there. That looked perfect. There's your Starlink satellites, Starlink V2 minis. Once again, look at this side of the recirculation manifold. That manifold, that gas generator manifold on that Merlin vacuum goes all the way around. This is the side that's opposite the turbine machinery. So the pumps are on the other side of the nozzle here. This is all nice and uniform. Right? Could it be one of the vent line cables? Well, Mouse, let's think about this. This is radiating heat on the outside. You can see that the film cooling is doing its job here because this part of the nozzle where the gases inside are still really, really highly compressed is being cooled right there by the manifold. The nozzle is clearly working correctly. If there was a combustion chamber or an injector plate or a fuel delivery problem here, you'd see this thing chugging along. It's definitely not. That engine is working just fine. This little flame, the little flames that happen here, that's totally normal. These little flames that you see at the rim of the nozzle happen because kerosene doesn't, there's no real good way to say this. Kerosene doesn't explode in a nice uniform fashion. That's what hydrogen is for. That's part of the reason why hydrogen flames are super clear. You could see right through it. Like a shuttle engine, you could see right through the flames because it's a very efficient burn. There are combustion byproducts using kerosene. So carbon emissions. You're getting unburnt carbon that's basically getting shot out the nozzle. That's normal. That happens all the time. That happens with every kerosene engine. Rocket Lab's engine does this all the time. That, once again, that could be combustion byproducts, or it could be fuel, unburnt fuel coming from the recirculator manifold. So here's the thing. The vent line cables have nothing to do with any of this. Remember, those vent line cables are there to thermally condition the engine before startup. Once again, they're controlled by what's called a pre-valve. A pre-valve is another pipe, basically, that liquid oxygen and RP1 can be used to move in a very small quantity into the turbine machinery on the engine to cool it down to get it to the right operating temperature. Has to be at the right operating temperature. It's like a car. You know, the car has to get halfway between the C and the H. It has to get up to temp to perform correctly. If you try to rev an engine when it's cold, it's really not good for it. Because same reasons as this right here. If all the metal doesn't heat up evenly and expand evenly, something can de-seat itself, and you could blow a head gasket if you rev an engine really, really hard while it's cold. Because the engine hasn't absorbed the right amount of heat. It's still cold, so you get you get some part of the metal heating up and other parts not. That's just kind of has to do with steel conductivity, but that's or iron conductivity, but that's another story. So I don't think the vent line pointing this way is going to cause a cooling issue on the nozzle here. This is clearly something with the gas generator. It's something with the gas generator. You're getting non-uniform heating, not because of combustion instability or anything. If there was combustion instability, this engine would have shut off immediately or blown up. That engine is working just fine. It's definitely up to thrust. Definitely up to thrust. This burn was perfect, interestingly enough. I know it's perfect because of the staging numbers. 138 at 27,366. That's fine. That is a good insertion. Starlink always puts itself into an eccentric orbit, goes around, starts the engine again, circularizes, and then deploys the satellites. Or at least out of Vandenberg for these polar missions, that's what it does. Now, look, check this out. Look at the difference in the bag inflation from here to here. Things started inflating like a balloon. Something is inside of that. It's LOX. I'm pretty damn sure. I can't recall in recent memory what RP1 that's been vented into a vacuum looks like. I do know that they dye the propellants. All rocket grade kerosene that goes into rockets is dyed red. It looks like blood. They do that so it's easy to find a leak if it does happen. You don't want your fuel leaking. Now, Also, you don't want your oxidizer leaking either. That's bad. Yeah, it looks like Jiffy Pop up in here. So, interesting thing here. Whatever this is that inflated these bags didn't happen right away. It happened a little bit later. And you're still getting non-uniform cooling on that thing. See what I'm talking about? This part of the nozzle is struggling to get up to temperature. It's starting to get there, but it's not exactly. Interesting that the leak started 2 minutes almost after. Now, why could that happen? Well, if you leak too much, you get solid oxygen accumulation here. Solid oxygen can temporarily plug a line. We know that happens because of Starship, actually. They had solid oxygen plug a line, and that's why some of the Raptor engines didn't restart on Super Heavy, interestingly enough. If I had to guess, this isn't some mechanical failure. If something mechanically fails, it'll fail. It won't just sit there and maybe fail 5 minutes later. All right? If whatever is causing that leak it would have failed instantly. It wouldn't. So it tells me that mechanically the configuration is like nothing is coming undone. That leak was just there, whatever it is, right? And what happened here was that the solid oxygen that accumulated from venting into a vacuum, when you vent liquid oxygen into the vacuum, it'll immediately try to solidify in that split second that it still has some energy inside of it. Because remember, temperature is a measure of how much heat is in something. If you're at absolute zero, so 0 Kelvin, there is no heat. It's the absence of heat. It's the absence of everything. Nothing can be 0 Kelvin and have it be matter. It's not really how that works. Universe starts doing some weird float point errors when you try to do that. Fun fact. It's not a float point error. We don't live in a simulation, I swear. So, it's very clear that whatever leak is going on here, solid oxygen plugged it for a second, but that solid oxygen came loose and started inflating the bag. Is that why the venting on the first stage stopped? Yeah, Ryan, most likely, yes. Now, interesting to note, Ryan, we didn't see any venting inside of the inner stage on the way up. That's strange, isn't it? Thermal conditioning should have caught this, right? Like we would have seen it on the camera if there was some solid oxygen inside, right? Weird, huh? We only saw gaseous oxygen being vented overboard. Now, here's the thing. At staging, there still might be some residual atmosphere up there, so you're not going to see solid oxygen. You'll see solid oxygen when you're up in the vacuum, like above 100 kilometers or about 62 miles. There may have been some residual gas atmosphere inside of that inner stage. There's always positive pressure or negative pressure vents on inner stages and fairings to make sure as the vehicle ascends that no air pockets get stuck inside of things. If there was some residual air in there, the oxygen would have immediately turned to gas, and then it would have looked like on the ground where you get a big vent in a cloud and that cloud just goes away. But we saw it on the outside of the vehicle, so we don't know if that venting went out of the negative pressure vent or if it went out of the venting line. Whatever it did, it clogged it for a second and then unclogged, because the vent started happening like normal and then it stopped. And then it started getting really bad. Some weird stuff to think about here, but that's what happens with solid oxygen when it leaks. It'll plug up a line for a second per SpaceX's own rockets, right? It'll plug it up, and then sometimes you could shake it loose. Now, something really bad is going on here. That leak, because I think it's blowing out all the solid oxygen that's accumulated inside of this bag, it starts to get worse. The Mila puffs up immediately before stage separation in the vid, and then it deflates a little bit, Tessa, indicating that whatever it is clogged that leak for a second and then unclogged it. When that ice got too much to deal with the acceleration, when the solid oxygen, it broke off. We see that all the time during restarts with the Merlin engine, with the Merlin vacuum, right? But clearly this thing is full of liquid oxygen. Now, once again, I don't know what that is. I'm not saying it was aliens, but it was aliens. Look at all of it. See that? That's bad. At the very least, that means you're venting liquid oxygen overboard, and there's no oxygen in space to make the engine. So you need that, but you're venting it overboard. It's kind of sus. Purge valve failure. I don't know. Let's get through the analysis here, and then we'll from what we can see. Now, once again, this, I would say, oh, the pre-valve vent system and the thermal conditioning system is failing completely. There's a huge leak in it somewhere. Yeah, there's a huge leak somewhere on the pre-valve system, because this problem only started to happen when they started to thermally condition this engine, when they were getting ready to fire it during stage separation. However, something is very strange here, because you're getting extremely non-uniform heating. See what I'm talking about right there? That right there, that's non-uniform heating. It should look like this, and should look like that. I don't think it's any coincidence that that's lined up with the gas generator. There's no coincidence there. It's lined up perfectly with the gas generator. So, whatever is leaking here is leaking in multiple spots. It's leaking overboard, but it's also leaking into your gas generator somehow. So, once again, what systems go to both of those things? I said before that the pre-valve plumbing does not go into the gas generator, but it fills the lines that go to the gas generator. So we're seeing a simultaneous leak inside of our gas generator, which delivers liquid oxygen, and also somewhere inside of the turbine machinery. Basically, it's on the inside of the turbine and on the outside. You can tell because the nozzle is not uniform. It's staying cold over here. Now, interesting thing here. The motor is still working just fine. It's still working. The thrust is good. The insertion was great. It's pretty textbook here. It was 27,366 at 138. That's fine. That's what we've seen. That's garden variety Starlink. Right? But you have non-uniform heating. So what would cause this to run cooler? Well, your gas generator is really freaking hot, obviously, right? It's super freaking hot. What would cause this to run cooler? Based off of what I said with turbine systems on turbo pump gas generator open cycle engines. More fuel would cause that problem. So, this is very much, I'm not sure if it's pre-valves for sure. I can't say. However, we know it has to do with startup. It has to do with where liquid oxygen goes during vent down, and it has to do with where liquid oxygen goes to your gas generator delivery system, your oxidizer gas generator delivery system. I don't think this has anything to do with the mainline plumbing on the engine. It's something to do with starting it. And it's something to do with where the propellant goes when where the propellant is going when you fire it, when you start up the motor. Now, once again, what would cause this to burn cool? It would cause fuel-rich. A fuel-rich mixture would cause this to burn very cool. Now, here's the weird one. Here's the weird part of this. If this went too fuel-rich, too far away from stoichiometric, which is the ideal rate of liquid fuel and oxidizer to make the most efficient burn, if it went too far fuel-rich, the motor would shut off, because if the gas generator isn't turning, your fuel pumps aren't turning. Right? So this is clearly just a small leak. But what's going on here is your gas generator is running fuel rich, more fuel rich than what you'd want, because non-uniform cooling. Right? There's not as much heat being delivered into this nozzle, and the film cooling, whatever it is just going straight out this manifold. I don't think that's the correct. The gas generator has the turbine on it, so the exhaust should be evenly mixed. Yeah, no, you're wrong. That's not right. They run fuel rich on purpose to prevent this metal from melting. I think the nozzle is cooler, more likely due to the extra exterior cooling. I disagree. Respectfully, I disagree completely. Let's keep going. So I mean, Aqualex, explain that one there. There's solid oxygen pouring all over the uniformly heated parts of the nozzle, and it's not doing anything. See what I'm talking about? So, bear with me here. Just bear with me before you say, no, I don't think that's right. No, just bear with me, okay? So, we clearly have lack of liquid oxygen, or a smaller rate of liquid oxygen being delivered into that gas generator. It's burning cold. It's burning fuel rich. And we're seeing the result of that right there. So more fuel is getting delivered here than oxidizer is for the film cooling. Once again, that would explain the non-uniform film cooling right there. This should be nice and even, and it's definitely not. So that tells me that something between... I'm not necessarily sure if the pre-valves go directly to the gas generator. They might. They might go to the gas generator in the turbine system, but your liquid oxygen delivery system for your gas generator and for your thermal conditioning is not working correctly here. That's my guess based off of what I'm seeing here. It has something to do with the start. Once again, the reason why, that engine's working just fine. That engine is perfectly okay. No, you don't get what I'm saying. The exhaust wouldn't have one cold spot is what I'm saying. The exhaust could be cold overall. Oh no, I get what you're saying. I'm telling you that's incorrect. I'm pretty sure that's not accurate. You're saying you'd see a lower uniform heat. You'd see it uniformly heating everything. Well, that's not how that manifold works. And please let me finish here before we start saying no. I don't think that's right. So once again, there's something here with I'd say gas generator pre-valve, or whatever your thermal conditioning system lines are, they have a leak. Now, the pre-valves are closed. Actually, you know what? I'm not 100% sure if the pre-valves stay closed. They might stay open because the pre-valves might deliver fuel and oxidizer to the gas generator. I'd have to go look. I'd have to go sit there and stare at a Merlin vacuum engine all day. So, but here's the thing, fellas. Once again, this isn't something with the main lines. We know it's not something with the main lines because that rocket engine that Merlin vacuum is healthy. It's fine. It's the propellant going around on the outside. That's not the good part, but clearly it does not care. It's working just fine. The nozzle is oscillating a little bit, but it always oscillates. If we were seeing some type of loss of mainline thrust, the oscillations on this nozzle would start to get really bad. It would start to get really bad. You run into all manner of problems when you have lower thrust than intended because you're screwing with the mixture. Weird stuff starts to happen when you screw with mixtures, out of family mixtures. Let's just say what it wasn't designed to go with. So I'll get more into conclusions here in a second. So clearly we have an oxygen leak. Whatever it is, it's not a big one. It's not a big leak, indicating that it's some type of secondary system. That I think we can pretty conclusively say that's what's going on here. This is a small leak. If it was a big leak, the motor would shut off. It's clearly working just fine. That motor is fine. We heard a little bit later from Elon himself. He posted about this. What he said was they tried to start the engine again and it didn't work. It exploded. So, once again, that suggests pre-valves. That suggests something where liquid oxygen is required to go to restart the engine. The pre-valve system. Basically the thermal conditioning system.
Stage 1.
Yeah, that's all wrong. That's really bad. It's there. If you could like take a knife and cut a hole in this, liquid oxygen or solid oxygen would spew out all over the place. See how the solid oxygen holds on for a second and then it starts to grow and it starts to grow because it's leaking more and more, and then when it gets too much mass, you're putting tensile forces on it. It separates after a certain amount, right? That's why it looks like it's snowing here.
Stage 1 FCS is saved.
For me, it seems that there is no complete optimal burning in the burning chamber. Ah, yes, the burning chamber. Oh, yeah. That's where the burns happen. Do you think they should have aborted to avoid space junk? No.
Stage 1
No,
transport.
human, relatively safe. The insertion altitude
Stage
was
2
like
FCS is
500 by 138, judging by your staging velocity here at second stage engine cutoff. At Seco 1, 27,366 at 138. That's eccentric. It's a little egg-shaped. For these polar orbit missions, they have a parking orbit like this, and then when they get up to apogee, they burn again and circularize, and then they deploy the satellites, and the satellites rise up.
Stage 1 landing
The
burn.
stage after that performs the disposal burn. Now, once again, Elon said that the engine rutted when they went to restart it
Stage
for its
2 is internal
circularization burn.
guidance.
Once again, this indicates startup systems.
Stage 1 landing leg deploy.
So you're saying they don't normally store their oxygen on the outside of the rocket? I'm pretty sure that's frowned upon, Pete, for a bunch of reasons. I mean, what do I know?
Stage 1 landing confirmed.
First stage performed great. Reused first stage performed excellent. There's some parts coming off of it. Do you think there's nukes in space? No. Now, once again, they cut the cast very quickly, and we did not hear a call for nominal orbit insertion, but this is working just fine. Those numbers, we know that these are telemetry driven. These numbers are not faked. Those are the actual numbers being downlinked from the stage. We know that those numbers are right. We've watched plenty of SpaceX casts to prove that. So look, 27,336. Now, something can be extrapolated from this. Look. You see how this number slowly starts to go down at like right when they shut the engine off? It was like tick, 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 tick. Usually it stops dead in its tracks, so something else happened there during shutdown that we didn't see. Now, it went down to 27,335, but that's because a deceleration in speed post-engine cutoff, 27,335 at 138 indicates eccentricity. So it's an egg-shaped orbit. It's not a perfect circle. Because if that number had stayed the same, that means it's circularized. It's starting to go down, which means you're going uphill to the highest point in your orbit before Earth pulls you back. It'll decelerate you, and then you start accelerating when it pulls you back. So we know there's eccentricity here. That's slightly below nominal there. See the blue line? The blue line should match up with that white line. They should be coplanar with each other. They're definitely not. So, interesting. Something that's like maybe 1 or 2 kilometers an hour short. Not a lot. Maybe like less than a meter a second short. Which, once again, that indicates that even with this gigantic oxygen leak, no matter where it is, the engine still is working correctly. That, once again, that suggests not mainline plumbing. That is not in the main line of propellants for the engine. It's something to do with the starting mechanism. No, it's circular. It's definitely circular. It's coasting uphill. So it was a little bit of an off nominal orbital insertion, but the velocities are right, which is interesting. So, conclusions on analysis here. Something is weird. Something went wrong with that Merlin vacuum's startup mechanism. The pre-valves, thermal conditioning system, something is weird with that. Do I have a diagram of where those pre-valves, and do I have a diagram of where the plumbing goes? No, I have no idea. I don't know. If I had to put my hat into the ring, though, I'll bet you it has something to do with the gas generator. Thermal conditioning of the gas generator, thermal conditioning of the turbine machinery. But then again, the turbine machinery is working just fine. Because the engine, once again, 27,000 is the magic number. It's circular. Well, not circular. It's eccentric. It's eccentric on the uphill ride. So on its way up, right? So once again, that tells me that the turbo pumps are working, the pumps are working just fine, and the gas generator is running a little teeny weeny bit cooler than it should. Even though that liquid oxygen is super freaking cold, right? Even though it's super cold, putting more liquid oxygen into that gas generator would get it running hotter, because oxygen isn't as good as absorbing heat as fuel is. Interestingly enough, you're leaning out the gas generator. If we saw a gas generator lean out, the engine would explode. It would just melt. You would have just seen it melt everywhere, but we didn't see that. And whatever this leak is, it's very, very small. It's not a big leak. So once again, that suggests not mainline plumbing. This is something to do with pre-valves, or I'm like 95% sure it has something to do with the pre-valve system or the thermal conditioning system. It sprung a leak. Maybe the pre-valve failed. Maybe the valve failed. Valves fail all the time. We just never hear about it, and it's never usually this overt. The SpaceX circularized right away for some missions. It depends, Elisers. For Starlink, they put it into an eccentric orbit for these polar insertion missions. SpaceX confirms it was a LOX leak. Yes, I understand that, Creeper. I'm basing my analysis off of that given information, but we did also basically prove it because of all the liquid oxygen that was spewing outside. Now, once again, everybody says, "Oh, that's liquid oxygen. Oh, that's liquid oxygen. Oh, yeah, that's absolutely like I can tell it's liquid oxygen. I've seen this before." Yeah, that's great. How do you know it's not RP1? Right? We don't, for sure, but we do. But we don't. I'm not saying I do, but I don't, but I do. No. If it was RP1, it would be blood red. They dye the propellants on purpose. So you could see if it's a leak, oxidizer, or fuel. Sorry if you answered this. I had a severe weather alert come through and had to pull my headphones off. Does SpaceX build every stage to man rating or just the Dragon ones? What would you do, John? You're trying to make a second stage every week. Would you have one configuration or multiple configurations? Which one of those favors mass production? Think about it, dude. Build them all to the same specification. You got it, buddy. Yep, that's it. That was a good question, dude. So, once again, it has to do with whatever your it has to do with thermal conditioning or gas generator delivery system. I do not know if the thermal conditioning system on these engines, basically the primer, is the same mechanism that delivers gas, fuel, and oxidizer to the gas generator. I don't know. Knowing SpaceX, it might be the same thing. You could use, why have two separate components? Your pre-valves are going to thermally condition your turbine machinery, but they're also going to thermally condition. They could deliver fuel to the gas generator. You don't need a lot of fuel and oxidizer to make the gas generator go. Besides, uneven film cooling is normal, probably due to manifold geometry. Okay, Aqualex, I'm not going to argue with you. Once again, you could say that, oh, well, it did that on DM2. You don't know if they're running that engine in a different configuration. What I'm basing my conclusions on is one of SpaceX's engineers on Twitter talking about black body radiation and how the Merlin vacuum engine works. It has to stay uniform. Now, I guess we don't really know what the what's the degree of uniformity that it needs. Clearly other missions have done this, but how do we know that's not some type of failure that happened that we never heard about? You don't know for sure. But at the end of the day, I don't think that necessarily proves, I don't think that changes what I think is going on. I really don't think so. Because even if that is normal. So, okay, if that is normal, that's still pre-valves. It really entirely depends on how their pre-valve and thermal conditioning system works. It really depends on that. It's just an additional note of information. My conclusion stays the same, even if that non-uniform heating on the nozzle is normal, which I don't think it is, but... Did I just miss another launch? No, Victory, you missed a launch failure last night. Thanks for the in-depth analysis. Also, hi, I bet a lot of money the SpaceX peeps will figure it out by the end of today, if not the weekend. They're quite good at making reliable rockets. Yeah. Once again, this is something, I'm pretty damn sure this has something to do with their thermal conditioning system and pre-valve actuators. Because if it wasn't, the engine would have exploded immediately. This is a secondary system that sprung a leak. Now, somebody asked a second ago, is it because of that crap that came off at the beginning of launch? Maybe. Let's think about this for a second. Falcon has launched almost 350 times with no issues that we know about, at least not a big enough issue for us to overtly see in any cast. I watch almost every launch, and even the ones that I miss, I go back and watch them just to be sure, just in case something like this happens, right? 344 missions since almost 6. You believe that, guys? That's the one that blew up on the pad because of solid oxygen permeation. That was in 2016. So, here's the thing. I think there are some reasonable things that we can draw conclusions to. This is absolutely not a design problem. The telemetry, the missions, the data, that doesn't lie. It's not a design problem. I'm going to bet dollars to donuts this is somebody not tightening a bolt down all the way, or somebody over torquing something, just like it is with Starliner. SpaceX is expanding its workforce like crazy at all launch sites for this launch cadence, so you might get newer people involved here. You don't have the same staff launching 12 times a year as you do launching 73 times a year. This was, I don't know if this was 73, this was their 70th launch and change this year. That's insane. You don't do that without scaling up your workforce. This sounds like somebody didn't tighten a bolt down or somebody didn't make this part correctly at the factory, but here's the thing. Every rocket motor that we know of for all new second stages gets tested at McGregor. It goes through what's called acceptance testing to make sure. That's basically a bench test. They fire them off at McGregor without the nozzle, right? So this engine would not have made it to a Falcon 9 launch if it didn't pass acceptance testing. So something has happened between when it fired and performed fine, because that would absolutely show up. You'd spray liquid oxygen all over the pad, all over your test stand, if that wasn't the case. Every engine gets tested, Willie. Every engine goes through acceptance testing. Watch McGregor live. Their engine's firing all the time. They test the engines individually, and then they test the Merlin 1D engines in a group on a first stage on a static fire test stand. They do the same thing with every Merlin vacuum. So something weird happened between McGregor, it passing acceptance testing, and going to Vandenberg. When was this engine made? When was it tested? How was it moved? Who moved it? Where did they drive? What roads? They could have hit a pothole and it could have knocked something loose. Rocket engines are engineered to that crazy tolerance. It's a dyno test. Basically, send it. Yeah, that's what an engine test stand is. It's just a dyno. Funny thing is, they use those test stands. That's how they verify an engine is working healthy. Like, trust me, they're not doing what we're doing and have some guy just look at the plume and go, yep, yeah, that's good. No, every engine has, it's not a dynamometer, but they have instrumentation to verify that the engine is producing the advertised amount of thrust. They basically, I mean, a dyno is a good way to say it. That's what a test stand does. You're not just sitting there. I mean, like, you could turn the engine on, but how do you know how much thrust it's making? You need a load cell, and you need that telemetry to tell you, to verify that it's working correctly. You can't just do what we do and look at the plume. That's why I wish I had some telemetry. If I had some telemetry in front of me from this Merlin vacuum, I guarantee you I could tell you what's wrong. Parent re-entry seen from Chile. Yep. Would this be classified as an unknown unknown? No, Dead Scum. This is not an unknown unknown. This is quality assurance. This is a QC/QA problem. Normally I don't jump on the, oh, this is a QA problem bandwagon that quickly, but once again, to the contrary, there's been 344 Falcon launches since anything remotely last failure, including 8 crew missions. 8 NASA crew missions, should I say. And then we've had multiple commercial flights on top of that. I don't think this has anything to do with the design of the Merlin vacuum. I think the Merlin vacuum is a sound design. The numbers don't lie, right? Good question. Honestly, with the best in the world by SpaceX, I'm surprised this doesn't happen more often. As you say, their launch rate is insane. I think this is just somebody missed a step somewhere. I think this might be a newer employee. Don't get me wrong, you shouldn't discipline that employee. There's nothing like, if you're going to sit there and not teach them how to work on your rocket correctly, well, the next time they'll absolutely fail if you get in their face about it. I think all that you do from spaceflight failures, you don't discipline people unless it's egregious, right? Unless it's on purpose. You don't discipline people, you learn. You learn. And I think that's what SpaceX is going to do. I really don't think anything is wrong here. I can say, and I'm not just doing that because I'm like, I want Falcon 9 launches all the time. If anything, they're launching too much. I can't cover all their damn launches. You know, if anything, it's weird saying this, but I wish they launched A, more during the day, and B, not as much because, you know, people, it's just another Starlink mission, whatever. It's not, again, they dropped the stage and didn't tell anybody about it. Other option is a crack somewhere under the thermal blanket, not counting out a crack on the bulkhead that grew during the previous burn. Then a RUD. Aqualex, once again, if there was any type of crack or mechanical failure, I think whatever the configuration of it stayed like that. Because, dude, if it was a cascading failure, this thing would have blown up. There would have been nothing left. We would have just seen it, and the numbers from the telemetry stop. Right? This is like a pinhole leak at best. Maybe something that's like that much. Like maybe 2 to 3 millimeter. It's not a lot. You wouldn't want more launches during the week? No, I lied. I want more launches. You're right. Cracking a solid line could do that. If somebody kinked the line too much, if somebody bumped into the motor with a forklift or something and didn't tell anybody about it, I'm not saying that's what's going on at SpaceX. And I'm not saying, it could have been an honest mistake. It's fine. But I really don't think anything is wrong with Falcon 9. Now, with that being said, the FAA is conducting a mishap investigation with SpaceX presenting their findings. Right? I don't think we'll see that big of a bump in the road, honestly. The last time we had anything near a mission failure was when first stage didn't light its engine correctly during supersonic retropropulsion and burned up in the atmosphere. And even then, there was not that. They were down for not a long time. It could be as innocent as a bad batch of material. If that was the case, Hellfish, it would have manifested itself in acceptance testing. RUD is still the greatest acronym of all time. Rapid Unplanned Disassembly. I used it to describe your divorce. Nice. So would you consider this a partial failure or a total failure? There's some debate going on with what to list this mission as. I would list this mission as a total failure because of what you linked earlier, dude. Or at least I think that was you. During Falcon 9's launch of Starlink, the second stage engine did not complete its second burn. Once again, that right there. See, this is what I'm talking about. This has something to do with thermal conditioning and the starter mechanism. It didn't. Elon said the engine exploded when they tried to start it again. Once again, it's the start. It could be pre-valves. It could be a bunch of different things. A follow-up is, how many good launches will they need to do to satisfy NASA for its next crew mission? I don't think they need more good launches, John. Right now, NASA's very data-driven with their spaceflight endeavors. If SpaceX can demonstrate empirically that this was a QA problem and nothing else, there's nothing wrong with the design, it'll be fine. They'll just... once again, guys, Falcon 9 is not going to be down for... It's not going to be down for like 3 or 4 months unless this is a catastrophic design flaw. But here's the thing. All spacecraft encounter teething problems. All launch vehicles encounter teething problems. If this was some kind of catastrophic design flaw, this problem would have happened a lot earlier. A lot earlier. This is something. I guarantee you this is something to do with the higher launch cadence. It is something to do with trying to go faster, doing the
Discovery,
same things
go and
quicker.
throttle up.
Hey, Rarest, 79-month resub. Yeah, this isn't a design problem. The Merlin vacuum design is perfect. It's fine. This has something to do with whatever happened with that engine between acceptance testing, integration, building, and putting back together. It could actually go back to manufacturing. I would say handling more than manufacturing, to be honest. Good point on the glowing crack idea. I mean, Oculus, yeah, you'd be around this mechanical stuff long enough. You know that, like, it's not a cascading failure. It either fails instantly, right? Or it stays the same and something else can cause it to instantly fail. Mechanically, I think the configuration of that Merlin vacuum engine didn't change throughout the entire ascent. Because once again, guys, it's not going to take much to throw that engine, to throw some of the parameters that's required for making that engine work out of whack enough to where it'll just blow up. There's a very, very fine difference between the engine working perfectly and the engine exploding. We saw it with SN11. We saw it with them trying to relight Raptors for Super Heavy on Flight 3. There's a very fine line. It's not much between an engine working perfectly and an explosion. It's really not a big difference. That, whatever that was a very, 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 very small leak. Because if it was any more, the engine would shut off. And that's why I think it has to do it has to do with something with their starter pre-valve mechanism. The pre-valve could have failed. Could have failed completely. And if it fails completely, well, you'd have to look into why that failed. Now, here's the real kicker. If it's the pre-valves that failed, I don't think the pre-valves are on the engine. I think they're on the stage. They might be internal, inside of the stage. So that problem wouldn't have showed up on engine testing. Unless they tested the engine with the stage, right? I know that SpaceX has a Merlin vacuum test stand, and they have a second stage engine test stand as well. I can't wait for the news article saying Falcon 9 grounded, no way to rescue stranded astronauts. Don't give them any ideas. Aren't they redesigning, slimlining the Merlin engine? It's possible, Humble. Once again, I don't think this is a design problem. This has very much to do with not a manufacturing base, your handling base. Dude, this could have... Somebody may not have secured this engine down when it was being moved from California, from McGregor back to California. The truck could have hit a pothole, bounced, and bent something. It's possible. I don't know with jets and helicopters where cracks grow slow enough to be tracked over multiple flights. The thing I want to point out, though, is that there's still a reason why they purge liquid oxygen on shutdown. If there was enough flooding the pipes and wires during coast, there are all sorts of problems. Yeah, exactly. Yeah, if the pre-valves weren't working, the engine was clear, like everything was flooded with liquid oxygen. Yeah, it probably rusted something out in the coast. If I had to guess, there's a reason. You're right. That's a good point. So what is SpaceX saying here? As a result, Starlink satellites were deployed into a lower than intended orbit. Yeah. See, that's what I mean. They had good or pretty good orbit insertion. Once again, not any mainline plumbing. It's not any of these big pipes. It's one of these small mother truckers. Now, I'm not even going to sit here and try and pretend like I can trace the lines on this. There's your 3 vents right there on the side. Wait. I said that those were the vents up there before. That's incorrect. The vents are down there. And there's the 3 other vents. Once again, this has got... See these things? They have different fittings on them. Some of them are red, some of them are blue. My guess is that's fuel and oxidizer. Interesting. The team made contact with 10 of the satellites and have attempted to raise their orbit using their thrusters, but they are in an enormously high drag environment with perigee, or lowest point of their elliptical orbit, only 135 kilometers above the Earth. Yep. and 135 is decaying, they're going to skirt the atmosphere and they're going to basically aero brake until they come down. Each pass through perigee removes 5 kilometers of altitude from the highest point. See what I mean? At this level of drag, our maximum available thrust is unlikely to be able to successfully raise the satellites. As such, the satellites will re-enter Earth's atmosphere and fully demise. They do not pose a threat to other satellites on orbit or public safety. Damn. Yeah, 138 is a parking orbit. But once again, this is why SpaceX puts at engine cutoff, this is why they put these satellites in the second stage in this type of orbit. Because if something goes wrong, everything will just burn up. Heck, guys, the ISS is in this type of orbit, even at 400 kilometers circular. If, God forbid, if we had to abandon the ISS and everybody has to come home and Starliner works right, don't make any stupid jokes. Right? Don't even joke about that. That's not funny. God forbid, if we had to abandon the ISS, it'll be down within probably a year by itself. We do that on purpose. What about the stage? Human, I think it's pretty reasonable to say that if the satellites with thrusters aren't able to maintain this orbit, the stage without thrust is absolutely not going to be able to maintain this orbit. Just a thought. That's actually really smart to do that. Everyone does that, Element, except the Europeans. No, their initial parking orbit was eccentric as well. They circularized it and then it broke. Yeah, but it's not going to burn up completely. Why do you think that, Human? Why do you think the second stage isn't going to burn up completely? I'm confused. ULA didn't build Starliner, Repairy, Boeing did. I mean, SpaceX disposes a second stage and it burns up in the atmosphere after every Starlink mission. You ever see any footage of a second stage part coming back down? The Merlin engine makes it to the surface. Yeah, I'm going to call bull crap on that one. Give me some evidence, please.
Discovery, go at throttle up.
27,000 kilometers an hour will not let anything through. That's right. Yeah, Human. I don't mean to call you out like this, but yeah, give me a picture. Give me a picture. Give me a picture of a second stage engine that's survived re-entry on the ground. You must have a picture somewhere if you're saying that. You must have some evidence. You must have seen an article or something. Did you see Phil's pictures of re-entry? Yeah, he's only linked it like 6 or 7 times at this point. Oh, I've seen it. Just trying to talk to you guys. Oh, I've seen it. I'd love it. I'd love it. Yeah, burned up over Chile and Argentina. That stage went afuera. Sorry. I know Boeing built Starliner, but it took me a second to contradict my... Yeah, repair. It's all good. Do they dump them in the ocean so we don't get to see how much of them make it to the surface? Yeah, generally you have something re-enter over water, even with people on board. Just saying. I just go by the fact that they deliberately deorbit every second stage or send it to a graveyard orbit. How does that possibly corroborate the fact that you're stating that any upper stage hardware makes it down to the surface intact? I don't understand. How does that prove anything? Don't you think some of these parts from that second stage might float? We would have seen debris. People would have, some of it would have washed up on shore. Now, don't get me wrong, the COPVs from second stages sometimes show up on shore, but you're saying the engine did. No, I don't I have no idea what you're saying at this point. I have no idea. Like, you lost me. I'm sorry, man. You lost me, dude, completely. Hey, Vulcan. I guess I'm getting a short vacation until SF51. Yeah, there you go. There are a few things that make it down sometimes if it's high enough drag to mass. We have some carbon. Yeah, I just said that. Yep. Yeah, I got you. I don't ever recall a piece of a second stage engine coming back down. COPVs sometimes, but what they do, guys, is they safe the stage by doing what's called inerting it. Probably with those pre-valves, if I had to guess, that'll get the stage to tumble when it hits the atmosphere, and when it tumbles, it evenly burns up all of the stage. Like if you re-entered it engine first, you might get some parts back, but they tumble the stages on purpose. I'm not completely sure, but I'm quite confident that the engine has enough mass to it to have a chunk of metal make it down. I think your math is incorrect, and you are demonstrating a fundamental misunderstanding of how thermal ablation works at orbital speeds. Anyway, so yeah, I'm not worried about the second stage or any of the Starlink satellites making it back down. They're gone. They're gone completely, based off of what we saw from people who track this kind of stuff. There's none of that's coming back down. I've always assumed that. Yeah, no, it's good, man. Just remember, I'm reporting the news. I don't mean to be so anal retentive about facts and evidence and stuff, right? But I have to, like, people are gonna come here, people are gonna listen to me. I can't be spreading the wrong information. At least, and don't get me wrong, sometimes I misspeak, sometimes I don't say stuff right. Sometimes I just don't understand what's going on. I ain't friggin' perfect, man. Neither are you. It's all good. But anyway, yeah, this kind of sucks. It kind of sucks. Yeah. The FAA, now NSF put in an inquiry here. Let's see. The FAA is aware an anomaly occurred during SpaceX Starlink 9-3 that launched from Vandenberg on the 11th. The incident involved the failure of the upper stage rocket while it was in space. No public injuries or property damage have been reported. The FAA is requiring an investigation. An investigation is designed to further enhance public safety, determine the root cause of the event, and identify corrective actions to avoid it from happening again. The FAA will be involved in every step of the investigation process and must approve SpaceX's final report, including any corrective actions. A return to flight is based on the FAA determining that any system, process, or procedure related to the mishap does not affect public safety. In addition, SpaceX may need to request and receive approval from the FAA to modify its license that incorporates any corrective actions and meet any other licensing requirements. Yeah, I tried, man. Misinformation, it's too late. So they're on pause. Guys, all right. This part is my opinion. So that whole thing about facts and reporting the right thing, just put that over there for a second. My opinion is that it's what I was saying before. This is absolutely a quality assurance problem. Like, I can say that with pretty reasonable conviction. I don't think there's any problems with the Merlin vacuum engine. I don't think there's any problems with Falcon 9. I think this is just somebody hammered when they should have used a screwdriver on a part. Now, that needs to be figured out. What happened to this engine? You have to look at the telemetry. You have to kind of extrapolate what went wrong with the engine. You don't have it in front of you. It's really hard to figure out what went wrong with the engine when it's burned up into a bajillion pieces over the Andes Mountains, right? So that's the exact reason why Starliner is still on orbit. It's on orbit because NASA's trying to figure out what funnies are going on with that service module so it doesn't happen again. SpaceX doesn't have that luxury because the second stage is totaled. So They're going to have to go and look at data. They have to look at the telemetry. They have to look at where the liquid oxygen was leaking, where they saw, like when the leak started, rate of leak, stuff like that. You can, from what we saw in the cast, we can determine, I mean, like I said, if I'm able to look at this and say that it has something to do with the pre-valve and the thermal conditioning mechanism springing a leak, I'm pretty dang sure they already know that. Yeah. If I was able to see it from this, they knew exactly, they probably knew what was going on as it was happening. I mean, clearly they knew something screwed up. You could just tell from the mission, from the people making the calls on the mission, like, look, listen, here, ready? Listen to the guy's voice, making the first stage call outs.
Stage 2 is in terminal guidance.
You hear the hesitate terminal guidance. So, listen. This was last night, FX. Yeah, the second stage failed.
Stage 1 landing leg deploy.
Landing leg deploy. Hear it? There's no excitement there. Landing confirmed.
Stage 1 landing confirmed.
See? They knew. They knew what was going on. Oh, they absolutely knew. Yeah, they knew that even though they got the first stage back, the second stage is toast. So that's what I mean. They probably knew what was wrong last night. I'll bet you they'll have their analysis handed to the FAA probably sooner rather than later. Yeah, exactly. Yeah, that's a first stage landing leg deploy. First stage landing confirmed. That's a, oh crap, something's very wrong. You could just tell by the tone of the voice, dude. Like, I'm not like, look at the body language. But that, dude, that's very telling. I bet you if we saw a shot of mission control, we'd see people doing this. Or this. It was actually probably mostly this, if I had to guess. You can always tell. When they show shots of mission control and people are doing this, something's wrong. They still have to work through the fault tree on all possible failure modes to prove that they know. Yeah, exactly. Yeah, that's right, Pete. Yeah, they have the fault tree analysis is what's going to take a while. QA problems are notoriously hard to find. But if you guys have ever watched me cover a crew launch, did you guys notice? And we get some insight into how SpaceX does things. You guys ever notice that they take pictures of everything? Like some guy tightens a bolt, take a picture. You know, some guy inspects the hatch. Take a picture of the guy inspecting the damn hatch. SpaceX documents every single step for quality assurance purposes. Pete, I guarantee you they'll be able to trace their fault tree a lot quicker than most, dude, because just the crazy high flight rate, man. They have more stuff to compare it to. Yeah, fault tree analysis is going to take time, though. I mean, I just did a basic one right there, ruling out a bunch of different things. I honestly think it's the pre-valves. Something's weird with the pre-valves. Or it's the pre-valves. I think the pre-valve failed. The LOX pre-valve failed completely. That would explain the mainline plumbing working just fine, and the venting way too much. I'm just turning that over. I want to make sure that that's... Yeah, I mean, dude, what else could it be? Like, don't get me wrong, guys. These engines are complicated. It's a rocket engine. It's complicated. That is what that engine is. It's complicated. But also at the same time, you can... If a car... Think about it like this. Oh, here comes the car analogy again. Oh, yep, didn't see that one coming. Right? If a car has a flat tire, is there anything wrong with the engine? No. A flat tire does not happen unless you did a huge burnout and you blew a tire, right? Like, in which case, your engine's working just fine. If you have a flat tire in a car, that doesn't mean there's anything wrong with the engine, right? If you have a headlight out, that doesn't mean your exhaust system isn't working correctly, right? Sometimes you might need to change the headlight fluid, though. I have some in the garage. Good. Right? rocket engines are the same way. Yeah, it's complicated. If you look at a car's engine bay, there's a lot of stuff moving around in here. But a lot of these systems are isolated in their own regard. Once again, you blow a tire doesn't necessarily mean something is wrong with the transmission. Right? That doesn't mean that at all. In fact, it's very unlikely. The fact that they weren't able to restart their engine, this whatever was going on started to happen during thermal conditioning, so Merlin chill down, right? And the fact that the engine was working just fine, through second stage ascent all the way to second stage engine cutoff, right? The fact that all those three factors right there, you can pretty much beyond a reasonable doubt know at least the area in which something failed. It's pretty dang obvious. Don't forget that cursed blinker fluid. It always leaks. Yep, just like hydrogen. Yep. Ah, yes, blinker fluid. I hear BMWs have problems with blinker fluid running out quickly. That's right, James, they do. But see these big boy pipes? Those are the big ones. Those are the big boy pipes. That's your fuel and oxidizer. And then down here, the gas generator, there's going to still be pretty big pipes going down to your gas generator because you have to deliver fuel and oxidizer to it. But I'm not going to sit here and pretend like I know what every single wire on this does. I absolutely don't. I'd have to have the engine in front of me. I bet you if I had it in front of me, I could figure out what most of this stuff does, but I don't. I'm just looking at a grainy picture, and frankly, the picture's probably low res on purpose. The heck is a blinker? Yep. Now, a couple of things to note, dudes, just in case you're curious about engine design. Notice that some of these pipes don't have any insulation on them, but some of them do. And also another thing to note, a lot of these fittings are color-coded. They're blue and red. If I had to guess, and this is a big guess, I don't know, like the pipes that have no insulation on it obviously aren't moving cold propellants. It's probably moving hot gas, right? That's probably moving gas instead of propellants. The pipes that have insulation on them are definitely moving liquids. That pipe right there has nothing on it, and we see it during ascent sometimes too. That's definitely a gas recirculator. It's right there. See it? Some type of recirculation gas mechanism. Like it could be EGR. Rocket engines sometimes have EGR. I mean, you could technically say that this closed cycle gas generator is an exhaust gas recirculator, but it's the exhaust gas not from your main engine. Now there's a valve right there. See that see that valve right there? That's a big valve. That's probably a main control valve if I had to guess, because it has a big pipe that's red that goes into an impeller right there. Do Merlins... they do take time to spool, Supercraft. That's why rocket engines take a couple seconds to get up to snuff. It's the gas generator spooling. True story. So see these smaller lines? Those are pneumatics. Pneumatics are used for valve actuation, amongst other things. I guarantee you it was one of these smaller mother truckers. So we know it's turbine machinery side, so it would be something in this area right here, because this is where the bag was inflating like crazy. That whole assembly about 2 meters tall? Yeah, Cosmic, but with the nozzle, it's like 5 or 6 meters tall. Vacuum engines are huge. They're a lot bigger than people think. Yeah, see, even their hardline fittings are color-coded. That's a plug, so that's some type of power system. That's some type of sensor and electrical system for the fuel. Once again, I think the stuff that's zip-tied with red is fuel. Stuff that's zip-tied with blue is oxidizer. That's just a guess, though. See, like, everything is anodized red down here. And these vent lines that we do see the engine firing, right? We see those vent lines working in nominal operation. Those ones are blue, and we see them venting liquid oxygen. Yeah. What's the remove before flight tag thing? It's probably some type of detent. I don't know. Could be anything. It could be a ground. It could be a bunch of different stuff. Red for fuel, blue for oxidizer just makes sense. Yeah, absolutely. The remove before flight is probably something that was required to install a component, but you don't need it for flight. It's like, think about if you're like assembling a piece of furniture from IKEA, right? You don't screw the last screw in and leave the bit from the screwdriver in it, right? But you need that to put the component together, right? You might have some extras at the end of the assembly, you know, you might. Some of these are anodized element, but some of them are blatantly zip ties. I mean, you can anodize aluminum red. That's an anodized piece right there. Absolutely. These are, yeah, AN fittings are all over the aerospace industry. They're everywhere. See these white lines right here? Sensors. Those are all sensors that would tell you the telemetry. These things kind of work like O2 sensors on a car. They're kind of a similar phenomenon here because that one is definitely a gas pressure sensor. That one's probably a gas generator mixture. If that's a huge guess, I don't know for sure. If I had to guess, that's probably mixture for your gas generator. I bet you that started putting up some red flags. Once again, I'm just, it's fun to look at, okay? Give me a break. There's some solenoids up there. And that's some type of proportioning valve up there. I'm trying to see if I can find where the pre-valves are, if at all. There's a mainline valve right there. See that big thing? That's a valve. That's what these valves look like on these motors. And it's around a gigantic line that's zip-tied red. So that tells me that that's the fuel line. To some extent, right? That could be the fuel line to the gas generator, but it moves up and into the impeller. See, that right there is your gas generator is down here somewhere. There's your liquid oxygen impeller right there. The hell's the RP1 impeller? Damn, EJ ignored my how's your day unsub, unfollow, worst streamer, emphasis on Kappa. How are you today? Interesting. Interesting. Could be a bunch of different things, dude. I'm going to go ahead and guess that it's, like I said, if I had to throw my hat into the ring, if somebody asked me my opinion, I'd say it has something to do with the starter mechanism. So pre-valves, but who knows? Anyway, guys, overall conclusions here. I don't think there's anything wrong. Seriously. I think this is a QA problem. Now, don't get me wrong. You have to go and figure out why this happened. If you don't figure out why this happened, you got to, and just keep sending them, you don't know if this problem's going to happen again. And that's why the FAA does their reports, right? Maybe a noob question, but how does the engine survive the combustion heat but not re-entry? I assume that with whatever cooling is happening on the engine, it would still be hotter than re-entry. Nope. Nah. So, if the engine is firing, sure, then maybe. Supersonic retropropulsion, Falcon 9 shoots its engines into oncoming plasma to get it to keep the engines cool and keep the whole Falcon 9 cool. That entry burn that it does. It's called supersonic retropropulsion. It's my favorite part. But the reality of the situation is that plasma is extremely freaking hot. We're talking 3,000 Fahrenheit. There's not many things that will survive 3,000 Fahrenheit for that long. Now, you got to remember, like, okay, if we really want to get into some nerd stuff, right? Okay. Like, say we have a small quantity of plasma. How much heat, how much energy does that have in it? How much of that? What's the flow rate? What's the flow rate of plasma? And that plasma that's accumulating, what is the heat flux from the plasma? How much heat does it give off? And what is it hitting? How much heat can that thing absorb? Right? Rocket engines stay cool. Rocket engines can stay cool for the most part because they're accelerating the gas really quickly past the metal, right? I mean, you're going to still need some cooling system on there, right? Like you need to fire your engines to keep it cool when you're, if you're going through reentry like that. But it really comes down to, how much heat is being introduced, how much heat is being fluxed into this thing, and what period of time. Now, here's the thing. During reentry, you're not going to get a linear curve of heat being introduced. Basically, it's not going to be the same. Peak heating goes up, then it goes down, and then the heating is replaced with pressure, right? Which can cause some heat, but nothing tantamount to heating up there, right? So we're not talking about how much the heat being delivered through reentry being the same. It goes up and then it goes down, right? So just because, and here's the kicker part, just because you can make it through peak heating doesn't mean that you're going to make it all the way, because once again, whatever you're trying to re-enter is only going to be able to absorb so much heat before it hits what's called critical mass. Think about like if you have a glass and you fill it up with water, right? Heat is quantitative, like water. They're not the same thing. This is an analogy. Shh. Okay. If I keep pouring water into this glass, it's just going to overflow, right? It'll eventually overflow and it'll go all over the place. Heat works like that. Heat energy is quantifiable. So say you have a block of metal and you start heating it up. That metal will only be able to absorb so much heat before the heat starts to overflow. When the heat overflows, the metal melts. Pretty simple. Now, that doesn't necessarily mean that you can introduce heat into some metal and the whole thing will absorb the heat and then melt, right? Some metals don't flux heat very well. Like if you did it with aluminum is very conductive of heat. You did it with aluminum, it'll probably melt one side first and then the whole thing will melt. Because aluminum is great at spreading the heat around. You did that with iron. You did it with a block of iron. Let's say you have a baseball-sized just chunk of iron, right? You heat one side, that one side will stay hot because iron doesn't flux heat as well. It can absorb more heat, though. A bigger glass, so to speak. Interesting, right? Because iron is super dense, like me. So, now, okay, what does this have to do with rocket engines? Rocket engines are only designed to take a linear amount of heat. The rocket engine firing is only going to flux so much heat. It's not going to increase it unless you throttle up or throttle down, etc., etc. But those changes in heat being fluxed into the rocket motor are nothing compared to the spike that happens during peak heating during re-entry. And your rocket engine can only absorb so much heat at once. Now, does it depend on what the metals are made out of in the rocket motor? Oh yeah, absolutely. You have a rocket motor made out of titanium, it might be able to do it. But even titanium will ablate. Titanium under a lot of heat. Titanium can absorb a lot of heat, but the funny thing is about titanium is that if you heat it up too much, it'll turn into a solid rocket propellant. Yeah, true story. Titanium burns real good. It's great solid rocket fuel. Not very efficient, very energetic though. Same with aluminum. Aluminum makes great solid rocket fuel. This is why if there's a plane that like bellies on a runway, like say a plane's landing gear doesn't work and it bellies on the runway and all the people get out, no one gets hurt, the plane catches on fire. That's why, the plane looks like it, when it lands, it's relatively intact. But, if you look at after it burns, there's nothing left. There's just a char mark on the ground. It's because aluminum makes great solid rocket fuel under the right conditions. So does titanium. Fun fact. Yeah. Magnesium too. Oh yeah. Metals in the right conditions can make great solid rocket fuel. In fact, the space shuttle and SLS's SRBs have aluminum flakes to keep in the rocket propellant. They sprinkle some aluminum dust on there. Yeah, gives you a nice uniform burn. It's called a stabilizer. They use it as a stabilizer. They don't use it as its mainline fuel. But the reason why those aluminum flakes are there is because when you cast your solid rocket propellant like you pour concrete almost, right? And just like concrete, some bubbles, some air pockets can get trapped in it. The aluminum is there for when the solid rocket booster goes off. The aluminum powder exploding fills that air pocket, so you get a nice uniform explosion. Can you explain what makes something a ceramic? It's made from rocks. I don't think I can off the top of my head. Yeah, because ceramics are metals. Rocks are just an amalgamation of metal and a bunch of other things. Like granite, for instance. The reason why granite is all sparkly is because it's a bunch of different metals. I just thought of a question. How do they keep the oxidizer fuel from rusting things? They purge the engine with helium. Oxidizer isn't fuel, Flykin. You can just say oxidizer. Could you talk a bit more about a Sabre engine? I watched a VOD where you talked about it, but I'm still not getting it. I didn't really get into Sabre engine plumbing, Dean, during that. Like, we scratched the surface of it, but yeah. Another way to look at it is to compare how much fuel was burned over the entire duration of launch to converting all that energy back into heat, mostly at peak heating. Yeah, it was a good question regarding reentry. Long story short, no. Reentry heating is way hotter, and it's hotter for different periods of time and longer periods of time. The temperature spikes up and down depending on your velocity. It's basically because it's a dynamic condition, it's a lot harder to mitigate than the fire that happens inside of a rocket engine. Plasma's hotter than fire, like way hotter. Think about, like, if another way to look at it, I guess, would be like if you had an acetylene torch versus a plasma cutter. An acetylene torch will take some time to cut through some metal. You got to heat it up, right? You got to flex some heat into it, right? Enough to, in a concentrated area. Plasma cutter will just, it'll just zap right through metal. Like, just, like a knife through butter, because plasma's way hotter. A ceramic is any of the various hard, brittle, heat-resistant, and corrosion-resistant materials made by shaping and then firing in inorganic, non-metallic materials such as clay at high temperature. There you go. Doggo is here, and Bree.
Hi.
Titan. No, come here, buddy.
All right, I'll be back in a little bit.
Okay, babe. Babysitting Titan for the next couple of hours. Doggo! Here, I'm gonna turn the fan on for him. Hi, Titan.
Discovery, go at throttle up.
I gotta clean up the office. That's my project for the weekend. Cleaning up the office so the doggo has a place to move around. My office is just filled with books about rockets. What are you doing back there? How's Titan? Titan's fine. Lie down, buddy. There you go, pal. This is a good boy. I'll get a Titan cam. I'll set one up this weekend. Don't worry. I'll get a Titan cam. Hey, bud. How you doing? All right. I got to get back to talking to these nerds about space. Cool. What will it take to unseat the shuttle as the goat in your mind? Something that's fully reusable. Yeah, the green screen screwing up is because I turned the fan on, guys. Starship. Cosmic, the day that SpaceX launches a Starship, Super Heavy comes back down, gets caught perfectly. Starship comes through re-entry and also gets caught perfectly, and they stack it back on top of each other. That'll be the day that it will unseat the shuttle as the goated lifter in my mind. You know, I know what people are going to say. Saturn V. EJ, with the Saturn V. First of all, I like the shuttle more than the Saturn V. Should we have canceled the Saturn V for the space shuttle? Hell no. Hell no. You'd be stupid to do something like that. But we did. What do you want? We're not perfect. So, you know, you say, well, what about Saturn V? Starship is Saturn V, but reusable and way more powerful. Yeah, but how many people did the shuttle put on the moon? We're talking about the lifter, John, not what it did. I think the shuttle is the greatest design spacecraft of anything. Second, probably only to the LEM. The LEM is insane. The Lunar Excursion Module. That's like pretty much right next to the shuttle. I like the shuttle more though, because I grew up with the shuttle, right? Super Heavy is an S1C on steroids. It is. Yeah, absolutely. Yeah, for sure. Anyway, somebody had another question and I forgot what it was. I apologize. Doggo. Yeah, Fractal with a tier 2 80-month resub. Popper. Oh yeah, Dean, you want to know about the Sabre engine. So a Sabre engine is half jet engine, half rocket engine. The Sabre engine specifically is using what's called a helium pre-cooler. It's basically got an air conditioner built into the intake. Yeah, it would be incorrect to call it an air conditioner, but that's generally the idea. So how does it work? A Sabre engine uses hydrogen and liquid oxygen. So when it's in air breathing mode, you're using liquid hydrogen as your fuel and the atmosphere as your oxidizer, like a jet engine. Now, what the Sabre engine does is, so it'll take off basically like a jet. When it gets up to the higher parts of the atmosphere, a problem that you have to deal with is not that the air up there is cold. You have to deal with that the air is hot. Now, why is the air hot up in the upper atmosphere? I thought it was colder up there. It is colder up there if you're not going 5,000 miles an hour. Yeah, it is colder up there if you're standing still. If you're flying in a jet plane going Mach 2 at 60,000 feet, the intake air gets absurdly hot. Yeah, like driving through the desert with no air conditioning hot. Probably hotter than that. So they have, in the intake, they basically have a heat exchanger right behind their cone intake, right? That heat exchanger uses liquid helium. So liquid helium gets pumped into this heat exchanger. Like it works like a radiator on a car, believe it or not, but it's using liquid helium instead of antifreeze, instead of propylene glycol or water. Depends on where you are. So helium gets pumped in. It goes through the heat exchanger. That heat exchanger, or it's called a pre-cooler in rocket science. The hot air comes in, gets introduced to the cold helium in the pre-cooler. The helium gets heated up. Helium is a great thermal conductor. Just like we were talking about how metals a second ago, some metals are great at absorbing heat. Some gases are really good at it. Helium is the best. It's like helium to absorbing heat energy is like what copper is to electrical energy. Like if we didn't have copper wires, we'd be screwed. Well, not screwed, but our civilization wouldn't look like it does now, that's for sure, right? Or silicon to a computer, but that's another story, right? So you have this heat exchanger. The helium absorbs the heat from the intake air and cools it, and gets it. It cools it and it slows it down for the most part. Actually, the cone intake is what slows it down. So it cools it, and that allows the jet engine, your hydrogen jet engine inside of this system, to work at a much higher altitude. Because what's wrong with a regular jet engine? So a regular jet engine gets up there, and eventually there's just not enough oxygen to be able to go higher. You run out of air. The Sabre engine solves that problem. And now, even then, you're going to get up above 100 kilometers, and there's not going to be enough air. There ain't going to be enough air up there for even the pre-cooler to work correctly, right? So when the pre-cooler that's another story. When the pre-cooler is where I didn't finish explaining the pre-cooler. When the pre-cooler turns that helium into gas, it goes back through a heat exchanger that's on the hydrogen plumbing line. Liquid hydrogen is super cold, so it actually preheats your fuel. It cools your intake air and preheats your fuel, which actually gives you a nice efficient combustion. Preheating your fuel is not necessarily the worst thing. It really depends on what kind of fuel you're using. Long story short, they need to find a way to take that liquid hydrogen and turn it into gas to work in the jet engine anyway, so you might as well exchange it with helium. That helium pre-cooler loop that's what makes the Sabre engine nuts. Yeah, it's basically an air conditioner built into the front of a jet engine. And that allows a Sabre engine to theoretically be able to fly 100, 120,000 feet and work just fine. Like, it'll just work like a regular jet engine. So you could just, you know, if you can make 100 kilonewtons of thrust at 100,000 feet, you can accelerate up there pretty damn fast because you don't have any drag. There's not enough air in the way to slow you down. So you could use that to basically do essentially what a first stage does on a rocket. Right? You get you up there. That's the idea. Now, what happens when it switches to rocket mode? The intake closes and the hydrogen and the liquid oxygen start flowing, and then you just basically have a rocket engine built into the back. The Sabre engine, when it's in air breathing mode, kind of bypasses the rocket engine. And that was the question that Ray asked about bypass engines yesterday, right? That's the closest thing that I can think of to a rocket bypass engine. Yeah, Sabre engines are nuts. Unfortunately, guys, the company that was working on Sabre engine, well, no, it's not unfortunate. The company that was working on Sabre engines had a huge breakthrough about 5 years ago. They had a breakthrough in getting their pre-coolers working. The helium pre-cooler, which was that was the tech. That's the tech. Anybody can make a rocket engine. Anybody can make a rocket engine. Anybody can make a jet engine. Getting those two to jive correctly and being able to pre-cool your intake air at high altitude is like, that's game changing. So the last thing we heard from Reaction Engines Limited, the company that was engineering the Sabre engine, was that they had a huge investment from Lockheed Martin and Boeing. And then we promptly never heard anything about it ever again. We still haven't heard anything about it ever again. So I'll give you three guesses. I'll give you three guesses what they're using Sabre engines for nowadays. Usually when a project like that goes quiet, fellas, they're either A, out of money, the investment speaks otherwise, or B, it works really well and Uncle Sam wants it for something. X-37 is a good case in point. The X-37A started as a NASA orbital test vehicle. Then the project just went black for a little while. We didn't hear anything about it. And then all of a sudden the Air Force is like, hey, we have a space shuttle, the X-37B. Everyone's like, that's the thing that NASA just had. Well, how do you have it now? And they're like, well, we have it now because we did. Because that's what we do. And they still use the X-37 to this day. So, yeah. Once again, that's just conjecture on my part. I have no idea what they're doing. Maybe they're building... Reaction Engines Limited wanted to make an SSTO. They wanted to make something that takes off like a plane and flies all the way up into space. Something, it was called Skylon. I have not heard any updates about Skylon or Sabre engines or helium pre-coolers since 2019, so. Well, we'll know in 30 to 40 years. Yep. Oh well. Anyway, yeah, that's pretty conclusive of that's Sabre engines, and before that, that was pretty conclusive of the of what's going on with SpaceX. I really don't think this is a big deal, and I'm not trying to downplay it. The empirical evidence from 300 plus prior Falcon 9 missions and almost 350 upper stage ignitions suggests that this is just a bump in the road, not anything else. Are we gonna game tonight? We're racing. I'm gonna race, Chief, after Flame Trench. We have Flame Trench in 2.5 hours. Thanks for doubling back for you. Yeah, no problem. I'd like to remind everybody that no matter what I'm doing, no matter what game I'm playing, etc., you can ask me a question about space. I'll take the time to answer it. But yeah, I don't think there's anything necessarily wrong with Falcon. I think it's fine. I think SpaceX will have this fault tree figured out probably in a week. Dude, I'm telling you, I've talked to people that work there. They are anal retentive about documenting every single step. Every single step. You don't touch that engine without somebody looking at you or somebody taking a picture of you touching an engine. That's how they've been able to achieve such high reliability, because there's insane accountability at that company. Like, if you don't tighten a bolt down and the rocket fails, they'll know. Oh, they'll figure it out. I'm telling you, SpaceX basically has like a Skynet computer in Hawthorne. I've had the benefit of seeing their server room. It's nuts. The SpaceX data center is insane. the SpaceX data center, you guys want to hear something nuts? I did not know about this until there was an interview with SpaceX's VP of flight reliability. Every single Falcon 9 launch, the telemetry from that launch gets downloaded to SpaceX's or uploaded to SpaceX's servers in real time. In real time. And if there's a part, not only does it get uploaded, it gets uploaded for archival sake. What SpaceX's computers and what their servers are designed to do is compare that flight against the entire catalog of every Falcon 9 ascent. So the computer is going to look for a mission that was similar. It's going to look for other Starlink missions, right? In this particular case, other Starlink missions out of Vandenberg. And then the computer will automatically compare the telemetry to other flights. If it finds something that it doesn't like, it's going to send an email to the person that's in charge of that department and say, hey, your gas generator wasn't working on this last flight. What the frick? Let's go fix that. It's actually insane what they're doing. That's the other reason why. That's what I mean about insane accountability. The computer is going to figure out what the computer is going to do their fault tree for them because that's what it does. Yeah, it's really crazy. That's how they've been able to make this so damn reliable. Every flight gets automatically uploaded to the server in real time and automatically cross-referenced against every single Falcon 9 flight going back to 2010. It's nuts. Absolutely insane. Yeah, it's crazy. This is one of the reasons why I say, and if you're wondering, like, EJ, how the hell do you know that? You don't work there. There was an interview that Aviation Week did with Bill Gerstenmaier. Bill Gerstenmaier is the VP of Flight Reliability. He worked on the shuttle program. I think if anybody, he actually ran the shuttle program. If I'm going to be honest. Pretty sure the guy that ran the shuttle program till the program ended and then worked on SLS after that knows something about reusing things that go into space. He's the guy in charge of that whole thing. Hi, we're emailing you about your Starship's warranty. Yeah, right. So, yeah, if you want to read more, it's an Aviation Week article with Bill Gerstenmaier. Yeah, guys, that's what I mean. They're gonna, if it's a QA fault tree, it might not do it automatically, but the telemetry faults will absolutely show up, and I bet you the emails were sent out automatically last night. Somebody came into the office today, and it was like that. It was like that Community meme where Donald Glover walks into the house with a pizza and everything's on fire. The SpaceX engineer walked into Hawthorne today and went, "Oh, shoot! Oh no!" Yep, that's broken. Oh, Creeper, there's tons of data, dude. That's, once again, that's how SpaceX gets, that's how they have such high reliability. That's how they do it. The computers are backing them up, and it's as they should. I'm telling you, SpaceX's mainframe in Hawthorne has a site. Thanks, dog. I really appreciate you stepping on my cell phone cord and pulling my cell phone off the table. Appreciate it, Titan. I have a dog here. I'm dog sitting the dog. What are you doing down there, buddy? Yeah, that's how they've been able to achieve such high reliability, because the computer is looking for faults. Must see Doggo. Show Doggo. I'll get a Titan Cam set up this weekend. He's putting his head on my lap. Why you gotta be so freaking cute, man? Not you, chat. The dog. Good boy. Wants his attention. Oh, he's got his solar system, Chewy. The solar system, Chewy, is a happy son that squeaks. You guys can't hear the squeaking. Hey. What are you doing, buddy? Here, come over here so they can see you. Get up. Oh, yeah, it's a good boy. It's a good boy. Say hi, Titan. He's like, no, I'm playing right now. Leave me alone. Can't you see I'm busy? I'm a very busy dog. I drive a Dodge Stratus. Right. No, don't knock over the VR headset, pal. Good boy. Yeah, I gotta clean up. I gotta clean this place up. There's not a lot of spots to move around, and Titan does not like sitting still. Anyway, if you see him crawling around in the background, you know who it is. The boy. It's the boy. All right. So, any other space news you guys want to discuss? Anything else? We have about 2 hours or an hour and a half until the flame twinge. Can't wait for the flame trench. Yeah, I basically got to go say everything that I just said again on flame trench in a second. So, you gonna keep him for flame trench? No, 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 no. Thanks for another great stream and analysis. Yeah, all good, man. I try. Are you after showing too? Yeah, I probably will. Racing doesn't start until 9, so. Amtrak is combining routes. Amtrak may be planning to combine Capital Limited and Silver Star. Interesting. Did the launch last night fail? Yep. Yeah, there was some type of locks leak, Canadian. Yeah, not good. I just got finished talking about it, dude. Don't worry. I'm like, it's not the event. I just talked about it. Go back and watch. No, it's yeah, something failed with it. It didn't yeah, something went awry, and the second stage didn't do its circularization burn, so all the satellites in the stage burned up. Sorry, I was out all morning. Yeah, you don't need to apologize, man. It's Friday. Knock back a brew and listen. Yes, it did fail. Do I think it's a big deal? Absolutely not. I'm willing to give SpaceX the benefit of the doubt, considering they've had 344 consecutive Falcon 9 upper stage firings and in flight and never had a problem up until now. And even then, guys, I can't ever remember the Merlin vacuum engine having a problem except not performing a relight test or not performing a relight in 2010. That was the last time I heard any problems from any Falcon 9 upper stage ever. I don't think this is an issue. I think somebody didn't tighten a bolt down or something. You'd be surprised how often stuff like that happens. Like, look at Intuitive Machines. Intuitive Machines didn't take the covers off of their damn laser rangefinders. They didn't take the damn covers off. So they left the lens cap on for their cameras to sense the ground on the moon. Does that make Intuitive Machines a bad company? Hell no. Intuitive Machines, one of the best in the business. I don't think it's an issue, Canadian. I really don't. I think SpaceX will have the fault tree analysis probably by the end of next week, and we'll be back to launching Falcon 9 sooner rather than later. Oh, hey, buddy. Want to look at chat? See chat over there? They did not remove before flight. It might be something that's stupid, Dean. You like, once again, if this was the first or second flight of Falcon 9, like Ariane, like this is clearly something that needs to be fixed, like Ariane's APU not working after 3 starts. Clearly there's something wrong there. That might be a design issue or controls issue. That is absolutely not the case with Falcon 9. You know why? Because it has 350 prior flights. It's fine. Really is not an issue. This is not a catastrophic problem. Thanks for knocking all my stuff over, dog. I appreciate it. You're a good boy. Not. Titan, that's a VR headset. What do you here? You want me to put it on you? You don't want the VR headset, do you? I think it fits on your head. You got a misshapen head. Oh, get away from the power systems, you dope. Hey! Get out of there. Sorry. He brought me a solar system Chewy toy. Ah, I can't deal with the cuteness. Stop it. Stop it. Stop it. Dog treats. Can't deal with the damn cuteness, man. Did you see Jared's post? How did his vet visit go? Fine. Yeah, he's healthy. He might have a heartworm. Yeah, we don't know because there's no documentation on him in his first his first year of life. So he might have a heartworm, probably doesn't, but he might, so we have to give him heartworm shots. That's kind of modus operandi with any dog. You hear this rocket engine simulator in development? No, but that's cool. I'll look at it. Yeah, exactly, Aqualex, yeah, that's right. App State, thank you for the dog treat bit tips. I do appreciate it. Jared's post. How did it, yeah, okay. And what's Rook saying? SpaceX has an incredible track record with Falcon 9. I can say from personal experience, they are very transparent when issues arise. I have no doubt they will arrive at a cause. His Chewy toy is stuck on my chair. Thank you. Thanks, buddy. I have no doubt they will arrive at a cause quickly and ensure the most cost-effective and reliable launch vehicle keeps delivering payload to orbit. This dog is a freaking bull in a china shop, dude. Yeah, I agree. Yeah, that's basically the same thing that I said. Can you not? Can you not? Get over there. There's probably going to be a delay to it, Dado, but we'll see.
Discovery, go at throttle up.
He went under my desk and started tapping the buttons on my second keyboard for the second computer down here. That's good. Hey, Churs, 16-month resub. What's wrong with a bowl in a china shop? Yeah, all of a sudden, the mouse started to move on the other computer, and the window for chat refreshed. This pup is pure chaos. I know, I kind of like it. Don't tell him that, though. Pretty awesome. I'd be surprised if there are any Falcon flights before mid-August. Well, prepare to be surprised then. I could say that with pretty high confidence, Roger. Do we need to get a baby playpen for him? Maybe. What's the doggo's name? Titan. Titan's his name. Oh. I didn't name him that, Pace, to be honest with you. That was his name from the shelter. That's how I knew we would be good friends. Because Titan missiles. Yeah. Yeah, I did not name him Titan. He's from a shelter in Tennessee. If I had to guess, he's named after the Tennessee Titans. If I had to guess. What would you have named him? I don't know. Me and Bree would have to come up with something. Actually, naming him after a missile is pretty good, dude. Atlas, maybe? Yeah, if it wasn't Titan, it'd be Atlas. Yeah. RS-25, fuel-rich stage combustion cycle. Artemis? Artemis is a girl's name. This is exactly what I wanted from chat. Falcon? Falcon ain't a good dog's name. Atlas is, though. Flight Dynamics Officer, Fido. That's in contention, Tom. That's good, man. Fido. He's a Flight Dynamics Officer. What's wrong? My mom texted me Fenway. Fenway is a good name. Hey, don't do any of that. Stop it.
All right.
He loves playing. This dog loves playing. Stop it. Stop. Hey, nope. Ignoring you now. Stop nipping at my finger. Hey, stop it. Oh, he talks. Yeah, he talks, Crumb. How old is he? He's 2. I'm sorry. He talks. It's funny as hell. He thinks he's people. When we wake up in the morning, he's lying down in the bed with us, but he's lying on his back like a human. He lies in bed like a human. It is the funniest freaking thing ever. He's lying like this. I'm like, what are you doing? He just looks at me. He's like, we're the same, right? I'm like, no. Titan. Why are you looking at me like that? Don't bark. Don't do it. I know you're going to. Don't do it. Anyway, I said don't do that. Here, look. Here, look. Solar system Chewy. See? Look, it's a happy sun with a happy Earth and a happy moon. See? Isn't that nice? It's just looking at it. This boy. You're lucky they like you, man. Because you're really eating into my space news time. Do you care about space? You care about space? Yeah? I like space. Imagine having him with your old orange backdrop, right? He's a good boy, but you can tell he's from the streets. You see him trying to, we're trying to teach him to not do that. See, he went after my hand for a second, but don't worry, he ain't gonna play. He just wants to play. Give me the Jake break. Give me the Jake break. La 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 la. This is Pupper News now. Yep. Pupper News Network. PNN. Does he have to go out? My mom's asking if he has to go out. No. He's fine. Bree took him out before she brought him in. Believe me, he likes going to the bathroom at 8 in the morning. Ask me how I know. Actually, he's calmed down a lot. He's gotten a lot more comfortable in the past week. How do you know? Because let's just say I don't need my alarm clocks anymore. Let's just say we don't need that anymore. Okay. EJ_PA, Pupper Agency. I prefer EJCA, Eric Johnson Canine Authority. I want Coco. I gotta go poopy. Okay. All right, dude. We get it. You're strong. Stop it. Come on. Damn it. Stop I can't reach the damn keyboard. I'm sorry, guys. I know you're coming here for Space News. I apologize. Primo had to go out, and we're trying to get him to learn to be in here for a little while because he's going to be gone for a week. And I'm not crating him for 10 hours a day. That's just messed up. Really, Pupper? Dog news is an acceptable alternative. All right, that's fair. You can see the doggo. It looks very awkward. Don't worry, I'm upgrading the cameras later so it doesn't look like that. Ernok left a week ago. Now you need to go tire him out. My wife just did that before he got up here, damn it. Come on. Do something. Wait, no. Who's in charge of who here? I am. Look at me. I am the captain. I am the captain now. No, she didn't. And the Camaro? It exists. Yeah, they don't, right? Came in here, messed up my green screen, knocked over my stuff. I don't do that with your pen. Tried to eat the moon, Chewy toy. 350 Chevy? What? Where? In that? No, 305. Yeah, we got to make the office doggo proof. Lie down. Good boy. Maybe I should teach him a lesson? Oh, okay. Hi. Are you familiar with gas generator? Closed cycle gas generator engines? Yeah? They have a single turbo shaft and a gas generator that's designed to run two fluid impellers that feed an injector plate. Yeah? Oh, he loves it. He loves it. Injector plate. Turbine machinery. Tap-off cycles. Full flow stage combustion. Oh, you like that one. Are you learning? I don't think this is how you train a dog. Hey, wait a minute. Hey, Titan. Supersonic retro propulsion. Oh, you like that one. You like that one. He made noise when I said that one. Nope. All right, Titan, Dad's got to get back to work. Sit down. Oh, he doesn't want to. Too bad. Time to work. All right. So, I thought Space News would take a little bit longer, but we got through most of the. Now he's chewing on my chair. Hey, don't do that. You have a Chewy toy at home. Chewy toy at home. This is your life now. It's fine. Is this the concept of operations Tori Bruno tweet? Stop it. He's chewing on the recliner handle. Yeah, it is. All right, so Tori Bruno just put dog toys everywhere. Yep. Yeah. All right, so Tori Bruno has a concept of operations here for using two vertical integration facilities for Vulcan and Atlas operations at Slick 41. Since I've been sharing Vulcan rocket ramp-up infrastructure progress at the pad lately, I thought you might be interested in this part of the launch concept of operations so you could see how the new Vehicle Launch Platform A and Vehicle Integration Facility A fit in. Couple of interesting things that I've noticed from this. All right, so this is a concept of operations. This is showing that how they're going to basically move rockets to the pad. It's pretty straightforward stuff. ULA stacks their rockets on what's called a mobile launcher, or ML for short. And then they basically tow the mobile launcher with the rocket to the pad, set it down on the pad, hook up the lines, and go. Yeah, that's right, Rem. I know. So, it's very interesting. They have VIF G over here, Vehicle Integration Facility G, which is USG, and then they have VIF A over here, Track A, Amazon. I'm pretty sure USG doesn't stand for United States Geological Survey. It's interesting because their concept of operations has one vehicle integration facility being used for government-only payloads, and the other one is being used for commercial payloads. It's very interesting. So it's very clear that they're going to separate their Department of Defense obligations and commercial mission obligations right there, which is actually super cool. I actually personally think this is really awesome, seeing old Titan ITL Causeway stuff get reused. If you're unfamiliar with Slick 41 and Slick 40, they were once part of a gigantic launch complex that was built by the Air Force in the 60s. It was called the Titan ITL, the Integrate Transfer and Launch Complex. So, like, you have 39A. Everybody knows about the VAB, Crawlerway, 39A, 39B, right? The Air Force built a similar facility over here. What you're looking at right here is the former ITL Causeway. ITL was designed for Titan. This, you know how much this explaining this is going to suck? The ITL is a huge Titan launch complex. I don't think I'm calling, damn it. Didn't think this through. So, the ITL had Slick 40 and Slick 41. That was kind of like Pad A and Pad B. Now, why is it 40 and 41, and why is NASA 39A, 39B? I don't know, because the engineers wanted different naming conventions. I don't know. How does positive traction work on a 72 Plymouth? It just does, all right? So, the ITL Causeway was obviously made up of Pad 40, right there, which is now a Falcon 9's pad, and Pad 41, which is Atlas and Vulcan's pad now. They were both used for launching Titan 3s, Titan 3Cs, Titan 3 Centaur, Titan 2 AS, Titan 3, and actually a bunch of other variants of Titan rockets. So, the Integrated Transfer and Launch Facility had a bunch of different parts to it. Like 39A, it had a huge VAB that had 4 bays in it right there. You could see there's 4 tracks leading to 4 different bays. They demolished that in 2009, I think. Yeah. Oh, 2007. Yeah, see? There was a gigantic vehicle assembly facility where they could have 4 mobile launchers and 4 Titan missiles get stacked right there. This was a 4-bay vehicle integration facility. From there, they would back it up, and they had a spare parking spots for 2 of the MLs. They would back the whole thing up, because these are train tracks, and they would roll the thing down the ITL Causeway. Which brings us to the first building here. This is the solid rocket motor integration facility. Right? Or called the SMARF, for instance. Not for instance, as an example. The SMARF is basically where you'd have a solid rocket booster here and a solid rocket booster here, because Titan had 2 SRBs attached. Titan 3 had 2 SRBs attached to the side. So if you were launching a Titan with no SRBs, you'd just roll right through this building, or you'd bypass it on this loop over here. If there was a Titan rocket that needed further assembly, right, you would attach the SRBs in this facility. That's why there's 2 cells on either side. You see these rooms right here. Is this building used nowadays? Yes, of course. SpaceX uses it to integrate payloads. If you were wondering. If we go over here, SpaceX assembles Starlinks in this building. Here, hang on. You can tell they have payloads here because of the way it is. Yeah, and Titan 4 as well. That's right. Yes. It was used for Titan 3 and Titan 4. So from there, it would roll even further, and there is a split. It would either go to pad 40 or pad 41. There is also a bypass area here. I forget what that was used for. Now, there's this building over here. This is the solid rocket motor, the former solid rocket motor assembly facility. So they would assemble the SRBs here, they would stack them, and they would integrate them in the SMARF over here, right? This building right here is what ULA is using as their second vehicle integration facility. They cut a hole in the roof, and they're actually building up. So they're building up so they can roll a mobile launcher in here, and actually they can fit 2 in there if you really want to know. They're rolling an ML in here and making the building taller so they can fit a fully stacked rocket in there, because before it was just tall enough for an SRB. In fact, if we go and look here, and we type in Vulcan mobile launcher, you can look at a shot inside of that building when they assembled, formerly Titan solid rocket boosters. You could still see the cells where they actually stacked the segments on the booster, and the two Titan 3 and Titan 4 SRB processing stools right there. They never got rid of them. They're still just sitting there. ULA is using this building to assemble mobile launchers right now, and then they're going to use it to stack rockets in eventually. Now it's called the Spock. That's right. Yeah, that's right. See, those are the old segment that's a segment processing stool, and then the SRB processing and integration stands are right here. See, there's 2 of them. Pretty cool, huh? So that's inside of that building right there. From there, with Titan boosters, they would either roll to, with no payload, they would roll to pad 40 or pad 41. On 40 and 41, it's probably better to look at 41 because it's more intact. SpaceX went in here and just cleaned up shop when they got the pad. These were part of the Titan launch pad operation. So Titan had a fixed service structure and a mobile service structure. There was a fixed service structure here on the west side of each pad. You could see the concrete block where it used to stand on right there. And then there was a mobile service structure that actually moved between here and here. Now, the fixed service structure was for... hang on. Let me look at it. Oh, those pictures are still here. Yeah, it'd help if you spelled Causeway right, idiot. Yeah, there's a picture of the VAB, their assembly facility. Yeah, there's the 2 structures right there. So you can see the fixed service structure here that the ML kind of went up against, and then there's the mobile service structure right there, and then there's a Titan Centaur right there. That's an early shot. That's like in 65 or something. Yeah, see, there it is. So, yeah, the fixed service structure was for commodities on the pad, and then the mobile service tower was to put payloads on. It was a vertical integration payload facility. Now this pad is used by Vulcan, and Vulcan and Atlas use a very similar system to Titan. Only they integrate payloads directly inside of their vehicle integration facilities. That's VIF-G right there in ULA's concept of operations. They're adding this part with the American flag to the Spock down here. They're going to add that part right there. They're going to make the building higher and put a bridge crane in so they can pick up rockets and stack them. Do you rail fan? Am I a rail fan? Yes. Yeah, of course. And then what actuates this whole mechanism are track mobiles if you're a train fan. Before, in the Titan era, it was EMD switcher locomotives. Trying to see if we can get a good shot of it. Titan 3C, Titan 3E, Titan 4. Yeah, they deactivated Titan 3 from Complex 41 in 77 in preparation for the space shuttle. Yeah, they use switcher locomotives to move the stuff around. Nowadays, they use trackmobiles. I'll admit, the trackmobiles aren't nearly as cool. Oh, hell yeah. See? Check that out. That's the Spock right there. That's the facility that they're that ULA is building on. Yeah. EMD switchers. They were Alco switchers in the early or in the 60s. In the 70s, they switched to these EMD locomotives. Yeah, those switchers are still pretty good. They're pretty good looking. Personally, I'm an Alco fan, but EMD is good as well. See the SRBs? That's actually, looking at these solid rocket motors, that's the Titan 4. I mean, it says it right there, but yeah, that's Titan 4 for sure. Pretty awesome. Anyway, yeah. Not sure what spurred that conversation, but yeah, the ITL. Oh yeah, the ConOps thing. Oops. Stupid. Sorry. The dog is screwing me up because he's sitting on my leg. So yeah, ULA is using 2 vehicle integration facilities, one at the former solid rocket motor assembly facility, and then they have the pre-existing one from Atlas V. It's an interesting thing to understand that Slick 41 can launch Atlas or Vulcan. It can launch either one. One pad can launch 2 different types of rockets, which is actually super cool. But yeah, either way, it's pretty awesome to have part of the original Titan ITL being used to put rockets together again. I think that's super cool. How are you? I'm great. How are you? Yeah, these buildings are super cool. SpaceX actually uses all of this for Starlink payload integration. Whenever you see pictures of a payload inside of a gigantic white room, that's what these are for. And they actually painted over the big USAF logo on there. That kind of sucks because that thing's iconic. I've had the luxury of driving down this road in the past, and dude, rolling up to this building and seeing the huge USAF logo is super cool. Smoked, I'm fine. How are you? Yeah, the railroad tracks are abandoned basically up to the SMARF. But the cool thing is that because ULA is utilizing this again, they actually re-railed the tracks all the way up until here. From here till pad 40 has the rails again, which is super cool. Can you still drive there? Yeah, of course. I can't right now. Like you have to get base clearance and stuff. I don't have that, not anymore at least. Why was it abandoned? Titan stopped flying. It was retired. Titan 4 was retired in favor of Atlas 3. But the Air Force pioneered this new strategy of leasing out pads to save money to commercial providers. They leased 40 to SpaceX in 2008, I think it was 2008, and they leased 41 to ULA for Atlas V. Atlas 3 used to launch ULA's rocket before Atlas V, and Delta 4 used to launch out of Slick 36 over here. Slick 36 has undergone some changes over the years. It's New Glenn's launch pad now. Pretty cool, huh? Yeah, there you go. A little bit on Launchpad history. But it's cool to see that ULA is reactivating because of an upswing in commercial launches. They're building another integration facility and reactivating some old Titan 3 stuff. That's super cool. What are the squiggly roads for? Which squiggly roads? I was looking at 36. What are we talking about? These are just access roads that go to the tank farms and stuff. Atlas 3 was super reliable, Zay. Delta 3 was not. Delta 3 launched from Complex 17. That's south. That's right there. After Delta retired in the late 2010s, they very quickly obliterated any part of that launch complex. Yeah, LC-17 was a twin pad complex for Delta 2, Delta 3, and then back to Delta 2 again. Oh, boy. That's some workers and resources stuff right there. Yeah, baby. The photogrammetric pictures still have the mobile service towers for Delta. You guys want to hear okay, this is a little bit of a tangent. You want to hear something cool? Delta 2. So Delta 2 has a core stage with an inner stage on top, and then you have your upper stage and payload fairing, right? And then you have SRBs. Delta 2, the mobile service towers, like if you look, the mobile service tower goes this way, right? So if, say you needed to start stacking a Delta rocket, right? The mobile service tower actually lifts up the Delta 2 core and then rolls over to the pad and drops it down. It's one of the few instances of a mobile service tower moving around with a rocket hoisted inside of it, which is actually super cool. Not a lot of people know that. Slick 2, which is Firefly's pad now. Yep. Yeah, so Delta actually picked up the core. Delta 2 picked up the core, rolled over here, and dropped the core down onto the pad. And then they installed the SRBs, and there were ways to feed the payload in. I forget how they did it. Oh, yeah, the bridge crane moves left to right. So SRBs would drive right here. They'd lift them up and put them in, lift it up, put it in, and then the payload in the upper stage would go here. They lift that up and put it in, too. It's actually super crazy. Like, see, this is just it's just a copy. See over here? They pick it up over here and then drop it in. See how the covered part of that service tower goes this way? Yeah. Pretty cool, huh? Just a little fun fact. Did Atlas 5 ever launch from Vandenberg? Yeah, Slick 3. They're retooling Slick 3 for Vulcan right now. Yeah, absolutely. Launched plenty of times out of Vandenberg. Yep. Believe me, launch pads are my wheelhouse. I love those things. Those are my favorite part. I don't know if you guys knew that. But anyway, yeah. Anything else? I think the big thing was the SpaceX failure, guys. Yeah. So already talked about the flight rate for Vulcan. Let's see. Very nice. Oh, let's see. Oh, look, geez, Nova, who asked him those questions? And with these improvements to infrastructure, what can we expect about Vulcan's launch cadence in the near future? And what is the ideal cadence that ULA is shooting for long term? Good question, buddy. That's two questions, though. You're supposed to star one and ask one question. What the hell's the matter with you? They're trying to do 6 this year, 20 next year if the payloads show up. That's a pretty high ramp. Steady state should be around 20 to 25. This basic infrastructure would support 35. Oh, look, another viewer. With that nuts cadence, will your water storage for the deluge need an upgrade? They already upgraded it. I actually talked to the guy that did that once, Erudite. Yeah, see? Yes and done. Yeah, me and Das interviewed a guy that works for ULA by the name of John Gadarowski. He's on Twitter. He doesn't post much, but he was the guy that was in charge of changing Slick 41 from an Atlas 5 pad to an Atlas 5 and Vulcan pad. And in those upgrades that they made, they upgraded the sound suppressor. So, yeah, good question. Thanks for sharing. Really curious. I don't think this guy wants it. Thanks for sharing. Really curious what the thought process regarding somewhat rebuilding the prior ITL infrastructure might be. If memory serves me correct, most of the Titan support facilities were demoed in 2005. Good question. Interestingly, VIF-A was the Titan solid rocket motor building. Yep. Is the final Smart for Spock high enough for rocket assembly? It looks like the Smart doesn't have enough height to accommodate the Vulcan rocket. No, we're raising the roof right now. Good stuff. Can you share pictures of that too? I think infrastructure is way overlooked. Ask and ye shall receive. See, they installed brand new tracks. Yeah, baby. Look at new tracks, nice, reballasted. Let's go. And that's a big old crane. Look at that thing. It's got the jibs and the mast. That's awesome. What other pictures we got here? That's a piece of the mobile launcher. And oh, look, a dually, boy. Very nice. And yep, there's them using that crane to reach up and over the building to lift the roof extension up. You can see they already started cutting holes in the roof up there. Oh yeah, wide nose Kenworth. Yeah, good eye. Hell yeah. Look at that. Yeah, that thing can pull that. That's pretty good, man. Dually with a bed cover. Check this image out. Kill it with fire, Trey Brood. Or Space Brood. Kill it with fire, please. Dually with a bed cover. Whatever. It's still cool. These are actually super good pictures. This one is my favorite, though, because you could see that they started re-railing everything. That's awesome. These tracks were abandoned since 2005. And frankly, if you go about 100 feet that way, they're still abandoned. But hey, better late than never. Look, they put brand new concrete ties in. Tracks have been reballasted. That's awesome, man. Pretty cool. You see this image from earlier this week? Is this the one of the MLP inside of that building? Yep. Yeah. Look at all the wiring that thing needs. That's a lot of wiring, man. Super cool. If only those were in City Builder graphics. Can you imagine if that was your desk? That's where you show up and go to work? Oh yeah, it's just rocket parts behind me. It's crazy. Those are the desks that always blow my mind, dude. Like, somebody's office is in the horizontal integration facility at 39, and somebody there is just doing their work, going to meetings with a rocket behind them. I go work on rockets again today. Cool. All right, dudes. What else do we got? Like, see, we're closing, and we don't really have a lot of time to play a game. We got about an hour. Huh. Yeah, poison. Yeah, exactly. Is that a rocket in the background, or are you just happy to see me? What's up, Roadrunners? How you doing? Flame Trench is at 5 p.m. I gotta get ready. I gotta start getting ready for Flame Trench at 4:30. It's 3:38 right now. We could play Workers. We could play Workers. We could play Fallout. What the dog doing? Dog's lying down. Play your favorite game. Workers. Ugh. Glory to ugh. All right, we'll jump in for an hour, and then we have NASA Space Flight presents the Flame Trench. So I hope you enjoyed this emergency space news. SpaceX did have a rocket fail last night. Long story short, it'll be all right. Let's name this small workers in resource stream. I deflated the price of oil, and it's not going well for me. Let's just say it's not going well. All right, cool. So Flame Trench starts in about an hour.